Hello everyone, my name is Abhishek and welcome back to my channel. So this is a very special video on the channel. In fact, this is a very proud video as well because in this video, I added 5 AI projects for DevOps engineers absolutely free of cost. Usually you'll find these projects in some paid courses or maybe behind some paywalls. We made it all free on this channel. You can go ahead, learn these projects. You can implement them within your organization. Or if you're interested, you can also show them as your freelancing gigs. There is absolutely no problem. Let me quickly walk you through the projects overview. Then you can go ahead, learn all the projects or projects that you're interested. It's up to you. Project 1, AI Kubernetes Agent. This is one project that I would definitely recommend and I would ask you not to skip because in this project, I'll show you how to build a Kubernetes agent, an enterprise level Kubernetes agent that can help you troubleshoot Kubernetes issues and also keep a track of previous Kubernetes issues. And this project is integrated with single sign-on, authentication, authorization, database, storage, everything that your organization needs. Project 2, AI Cloud Cost Detector. This is a very interesting project. Usually within the organizations, cloud costing is a key problem. So we will build AI Cloud Cost Detective that will provide the cloud resource billing at very granular level, and it will also help you understand how to reduce the cloud cost in future. So it will perform the FinOps engineer role for you. Project 3, AI Kubernetes or AI DevOps teammate. Now, this is another interesting project. Basically, in this project, I'll show you how to build AI DevOps teammate with the help of RAG, MCP, and skills. And this teammate can help you with your day-to-day activities. But Abhishek, ChatGPT can also help us, or Claude can also help us. But this teammate has a complete context of your organization. So it will not respond with the answers on the internet, but it will respond according to the scope of your organization or according to the requirements within your organization. Again, a very useful project. Project 4, AI Kubernetes Upgrader. Now, this is an optional project. If you are working on Kubernetes upgrades, this project is very useful. With the help of AI, you can upgrade the Kubernetes cluster. So basically, this Kubernetes upgrader, it will perform all the checks for you. And it will tell you if your Kubernetes cluster is ready for an upgrade. And finally, project 5, Terraform Drift Detector. A very, very useful project where you will learn how to implement Terraform drift detection. We will build this entire project using Cursor. So basically using an agent, we will write this entire code and it's a very complicated code. When you look at the project, you will understand. And this is all done, as I told you, with the help of AI. So these are the 5 projects that you will find within this video. You can find timestamps in the description. Like I said, if you want to watch all the projects, you can go ahead and do it. Or if you're interested in a specific project, go check out the timestamps. Once again, finding something like this for absolutely free of cost is very, very rare. So I would request your support to the channel. If you haven't subscribed to the channel, please subscribe. Or if you think this video helps someone, just share this video with someone who is learning DevOps with AI. Perfect. Let's get started. There you see error image pull and the next status would be image pull back off. Perfect. Now we should see this. Let's say there is a developer finding it difficult to understand what went wrong with the cluster or what went wrong with the pod. They can come here, click on it and click on investigate the cluster. If they have access to the cluster right now, this is using my kubeconfig file. So I have access to it. What is it doing? It is investigating, checking the pods, reading the logs, analyzing the events, inspecting the deployments, checking the networking, giving this entire information to AI. Basically, we are using Open Router here and root cause found. You can see it performed the root cause. What does it say? The pod Nginx image pull backoff is in pending state due to an image pull error on non-existing image tag. It exactly explained you the issue. This is the image that you're using, and this image is invalid image. Just use the valid image. Something like Nginx latest. It also gave the kubectl command. This is the confidence score. AI is confident that the command is 80% correct, or the investigation is 80% correct. There is a reason for it. Why is it not 100%? Because there is a possibility you might not want to use this image. Maybe your organization wants to use a different image. And it also says, how do you prevent these issues in the future? Probably use the CI/CD checks. On top of that, we also have the recent investigations. Till now, we did 3 different investigations, and all of the information is stored here. Where are we getting this from? We are getting this from the InfoJ database that we configured. And this is also automatically configured. We have investigations table and we have investigation progress. All the previous investigations progress is here, the different steps that were performed. And these are the different investigations. First issue was because of core DNS. Second issue was because of Nginx crash, the crash loop backoff. And the recent one is because of Nginx image pull backoff. The same information is shown here. Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's build an AI Kubernetes agent. We will do this in 5 simple steps. Step 1, problem statement. So we will start with understanding what is a real problem statement. Why do you need an AI Kubernetes troubleshooting agent and how it can help organizations in real time. Step 2, tooling. So we will understand what are the different tools that we are going to use to build this end-to-end project. Step 3, architecture or the high-level design. In this step, I'll walk you through the different components that are involved in building this project, and I'll also tell you how each component interacts with other. Step 4, end user workflow. So in this step, you'll understand how an end user interacts with this agent application and how the agent application returns the response back to the end user. Step 5, the final step, is the implementation. And you don't have to worry about it. I've created a GitHub repository where I'll share you detailed steps on how to implement the project. So after watching the video, even you will be able to create your AI Kubernetes agent. All the useful links are in the description as well as the pinned comment. So without wasting any time, let's start with creating the project. Let's start with the problem statement. Why do you need an AI Kubernetes troubleshooting agent? Simple. Kubernetes today is widely accepted as a target platform. Whether you're working on traditional software workloads or you're working on AI workloads, ML workloads, Kubernetes is where these workloads are deployed. While Kubernetes is very popular, troubleshooting Kubernetes is a major challenge. It's not that easy as it looks. Let's take an example. Imagine an organization called XYZ. A DevOps engineer within this organization deploys one of their application as a pod onto the Kubernetes cluster. And DevOps engineer shares the information of the pod with the development team. For some time, let's say the development team or one of the developer is able to access the pod, but after a while, there is some issue with the pod. Developer is not able to access the application. Now, in this case, for developer to troubleshoot the issue, developer should have understanding of Kubernetes, understanding of kubectl commands to use, and different issues on Kubernetes. Because the pod might have gone down because of liveness probe issue, readiness probe, crash loop backoff, image not found, or n number of Kubernetes events. Now, this is practically not possible. So developer would reach back to DevOps engineer asking to troubleshoot the issue. Now, this is a major challenge. DevOps engineers, most of the time, they spend on troubleshooting the Kubernetes issues because it is not a single developer. Multiple developers across different teams would reach out to the DevOps engineers to troubleshoot issues with the pods or Kubernetes clusters. This can be avoided if you build an AI Kubernetes agent. Of course, this cannot be completely avoided, but significant amount of developers' time and organizations' time can be reduced by building an AI Kubernetes agent. How would this work? Very simple. A developer or a cloud engineer would build this platform and make this platform live. Now, a developer would get to the platform, access the user interface of the platform, access the cluster on which they are finding the issue. If they have access to the cluster, they would click on the cluster and or the relevant pod, and on the user interface, that is on the front end, a clear and detailed issue with the pod is displayed on the screen to the developer. Let's say if it is a trivial issue, maybe the memory issue with the pod or the CPU throttling issue or image issue, developers can fix the issue by themselves. Or if the issue is complex that developers cannot fix it, they at least have more context. Now, with the complete context, they can reach out to the DevOps engineering team. So the initial troubleshooting time of DevOps engineers is saved. So this way, AI Kubernetes agent can add significant value for the organization. Okay, now let's move to the next step, the tool set. The best part of the project, tool set is minimalistic and the tools that we're going to use are very, very powerful. For Kubernetes cluster, we will go with kind so that you can spin up a local Kubernetes cluster. For front end, we will go with JavaScript family. For programming language, we will go with Fast API or Python. So using Fast API and kubectl, we will connect to the Kubernetes cluster and we will get the required information. Most importantly, for database, for storage, authorization, LLM integration, and even for deployment of this application, we will go with InSforge. We discussed about InSforge in some of our previous videos, but for people who are new, InSforge is an AI native backend. So you can create a free account with InSforge and you can connect InSforge to your AI coding assistant. It can be anything. You can be using Claude Code, Windsurf, Cursor, Codex. You can just connect that using a click of button. And once it is connected, in plain English, that is using prompt, you can configure your database, storage, authorization, deployment, and even LLM integration in InSforge. So that's why we will go with it. You might have a question, Abhishek, why not go with Postgres? Or maybe why not go with Supabase? Simple, InSforge is designed as an AI native backend, so it makes your life much easier. On top of that, even the tokens that it would take on your coding assistant or on your agent will be significantly less if you go with InSforge. We will see that in the implementation part. So just to repeat, for the toolset, we will use kind for spinning up Kubernetes cluster. For front end, we will go with React. For programming language, we will go with Fast API or Python. And for all the other things like DB, storage, authorization, deployment, and LLM integration, we will go with InSforge. Now that the toolset is clear, let's move to step 3, understand the architecture and high-level design of our Kubernetes troubleshooting agent. You can see there are different components here. Let's try to understand how each component works. As the first thing, user interacts with front end. Within front end, user can connect to different Kubernetes clusters, saying that authorization plays the key role. Because not every user should get access to the production cluster and troubleshoot the production cluster. And this authorization is taken care by InSforge. We will see in the implementation part how is that done. Now let's say user has access to the cluster. Then the next component is the Fast API component. Fast API makes use of kubectl, connects to the Kubernetes cluster and gets the information like the pod information. It can be pod health, it can be the pod status. It also collects logs from different Kubernetes resources. And it also helps with the network information. It inspects the Kubernetes network to see if there is any latency or any issue with the Kubernetes network. Along with that, it also gathers the information of deployment and Kubernetes events. Now, once all of this is done, this information, because this is a lot of information, it is sent to LLM or AI. And again, we will make use of InSports Open Router in this case. Now, if you go with OpenAI, or let's say if you go with Anthropic API key, you can also do that here, but it will be very expensive for you. Open Router is multiple times cheaper when compared to OpenAI or Anthropic API keys. Within the InSports platform, because we are already creating an account and because we are already using it for different purposes, we will also make use of the Open Router API key that is going to provide. Now, once this information is taken by LLM would analyze the information and summarize the issue for us. Instead of just returning the information to the end user on the front end, we will also store this information on the InSports database for the investigation history. Let's say you want to see the list of issues that are identified, or you want to see the track of issues in last few days. You need an investigation history. So again, we will store that on the InSports platform. So this is the high level design or the architecture of our Kubernetes AI agent. You can also find the architecture on the GitHub repository. So if you head to the GitHub repository and look at the README file, you will find high level architecture, the same thing that we discussed on the whiteboard. Along with that, you will also find the end-to-end user workflow. So this is our step 4. Let's understand how the user workflow looks like. When user clicks on investigate cluster, so user would look at the front end. User would click on investigate cluster to understand what's exactly wrong with the cluster. Front end sends the API request. And as we learned, this is where authentication takes place. Authentication is performed, and once the authentication and authorization is performed, request is sent to the investigation layer, which is Fast API. Fast API performs verification of the pods, it reads the logs, it analyzes the events, inspects the deployment, checks the networking, and once this is done, it sends the information for LLM reasoning. As I told you, we will use Open Router through InSforge API key. On the InSforge platform, you will find Open Router API key. Using that, we will send this entire information to LLM reasoning. LLM would perform the root cause analysis. It would come up with a suggested fix. Instead of just returning that to the end user, we will also save that information within the InSforge platform for investigation history. And also we'll show the end user real-time progress updates. So this is how end-to-end user workflow would look like. Now let's move to the implementation part. We will implement component by component. And for the implementation, I will use Cursor IDE. It's up to you. You can use any AI coding assistant or any coding agent. I'll share the prompts in the GitHub repository. You can literally use the same prompts. So if you just head to the prompts folder, so these are the 5 prompts that I'm going to use. Let me go back to the cursor, open a folder. There you go. We will start with implementation now. There are 2 prerequisites. One, you need a Kubernetes cluster. So let me pull my terminal and create a local Kubernetes cluster. Kind create cluster. Let me just call it troubleshooting cluster or Kubernetes demo cluster. In no time, you will have the cluster created. You just need Docker running on your machine. Then the second prerequisite, we should have InSport setup. And again, this is also simple. You just need to go to the InSports platform. You can find the link in the description. Just sign up, create an account with it. I've already created an account. So I'll just click on the dashboard. I have some previous projects. I've used these projects. I've demonstrated on the YouTube channel. You can set up your free account and you can start your first project for free. I'll use one of the projects here. Like I've just created this project and I will set up the cursor integration. So you can literally integrate with any of the coding agent. This is what I was talking about. This is the best part. If you are using InSporch, you can configure your storage, you can configure your database, the model gateway, everything through the cursor IDE or any coding assistant that you use on day-to-day basis. You don't have to get here, you don't have to manually configure anything. So I'm using cursor, I'll just click on install. Either I can do through the CLI, I can just provide this prompt, or I can just use the MCP, install to cursor, paste prompt to cursor. Let me do this. Okay, open the link. It opened cursor for me. I'll click on install. And if you notice here, it says 17 tools are enabled. So the InSforge MCP server is configured and it has these 17 tools which can help us configure the InSforge platform through cursor IDE. That's all. This is what you have to do. And just to verify if everything is good, you can paste the prompt. So this is the prompt. This is just for verification. I'll just paste it here, change to the agent mode. I'll go with auto just for efficiency. I'm using InSforge as my backend platform. Call InSforge MCP fetch documentation tool to learn about InSforge instructions. This is just to verify if your InSforge is configured well. Or let me just switch to one of the models. I'll go with Composer 2.5. Nice. So run fetch docs in InSforge. Let me allow list of MCP tools. We have the required information. That means the configuration is done. We have set up Kubernetes cluster. We have configured InSforge. So we are all set to build our Kubernetes troubleshooting agent. So let's go to the prompts folder on the GitHub repository. It will take a lot of time to write these prompts. That's why I save them in the GitHub repo. So this is the first one, project setup prompt. What is this going to do? This is going to set up the folder structure for us. Because this is going to be a decent application, the size of the application is going to be decent. So instead of having everything in a single file, we will create a folder structure. So the project is also modular. So this is the prompt. Let me quickly go through this for you. What we are saying cursor, we are building AI Kubernetes troubleshooting agent. This is the architecture. This is the example flow. The goal of the project is to create using fast API backend. We are asking it to use Next.js frontend, or you can go with React as well. The Docker setup, environment variables, and this is the tech stack to use. And when it comes to the project structure, this is the one that I asked to use it. Now it's up to you. If you want to go with a different project structure, you can also go with it. Just head to the repo, modify the prompt. So let me copy this entire thing. I'll open this in the raw folder, copy this, get back to cursor and paste it here. Nice. It is setting up the required files and folders for us. Probably this is going to take 2 to 3 minutes. So the execution is complete. It just took like close to 2 minutes. The folder structure is created. Now we have the backend folder. We have the front end folder and we have a basic Docker Compose file to run the application along with the agent locally. Right now, it just created basic front end. In the dark theme mode, it also has very minimalistic options. Let's go ahead and see. If I open localhost 3000, okay, so this is the one that we have at the moment. It has also taken care of CORS. So good first step. Now let's go to the second one. So this is the prompt 2, Kubernetes investigation engine. Again, we are providing cursor with the information. If you observe carefully, in every prompt, I have provided the user workflow so that cursor is very clear with what exactly we are going to build. And this is going to work with any AI agent that you are going to use. The goal, this layer should behave like junior DevOps engineer, collecting evidence from before the AI reasoning starts. Important, we are not still implementing the AI reasoning. That will be implemented in the third component, the AI reasoning part. We are only collecting Kubernetes troubleshooting data. And I've also provided what kind of data that it has to collect. And individually, I've provided it information like the kubectl executor, what is pod inspector going to do, what is logs collector going to do, events analyzer. As I told you, if I type this entire prompt, it is going to take a lot of time. So that's why I've created this and put this in the GitHub repo. Now let's also copy this. I'll open this in the raw format, Control A, and paste it on the cursor. There you go. So it created bunch of containers for the Kubernetes agent. It was able to figure out kubectl as well, and it is handling errors around the kubectl. Like when kubectl tries to fetch the information, there can be some latency or there can be some retry related issues. It's also handling those issues at this point. Looks like it's done. These are the new backend modules that it added. So if you go to the backend, now we have within the backend Kubernetes, you can find deployment inspector.py, you can find event inspector.py, Kubernetes executor, logs collector. So using fast API, it is getting the information from the cluster. And for that, it is using kubectl executor. As expected, everything looks good. Even in the output summary, it provided this is the information that it is collecting. So it is collecting crash loop back off, image pull off, image pullback of pending, error, OM killed, most common error information from the pods. It is also connecting different logs from the cluster. When it comes to events, it is looking for these events, deployment, and also network, like the missing endpoints, selector mismatch, and DNS issue. The good thing is that in case we want to add more information, let's say in pods, I want to gather information for liveness probes and rubbiness probes. It's just modifying the prompt. I can add one more instruction and tell cursor also monitor the liveness probe and readiness probe. And our agent will start doing that as well. Cool. So we are done with the step 2. Now we also have the fast API backend. Now let's go to step 3. So we will go back to our GitHub repo. Component 3, add AI reasoning engine prompt. If you remember, we are doing everything according to the architecture. Step 1, step 2, step 3, we are going with the flow. So the prompt 3, we will add the AI reasoning. This is the prompt. The Kubernetes investigation layer is complete. We are done with this. We can now complete Kubernetes troubleshooting evidence. Example, these are the components. This is the architecture. Again, I am providing the agent with the required architecture. What is the goal? We want to make the system intelligent. Previously, in the second prompt, I told it the goal is to behave like a junior DevOps engineer, collect information from the cluster. Here, in the goal section, I'm saying act as a senior Kubernetes SRE and perform investigation. I mean the AI investigation. It should understand Kubernetes failures, correlate the logs, events, deployment state, find the root cause, suggest the fixes, and generate confidence score. Why are we generating this confidence score? Because this is the platform that we are building. We are making use of AI. So we can also tell developers AI is only 60% confident about the issue, or AI is 100% confident about the issue. Perfect. So let's go back, click on raw, copy this entire thing and paste it on the terminal. Now this will implement the AI layer as well for us. And in the prompt, I've provided the instruction very clear. Go with open router via insforge key. But Abhishek, where will you get this open router via insforge key? If you go back to the platform, there is an option for model gateway. If you head to this section, start using the model gateway active open router key. So I'll just copy this and I will put this in the .env file. Let's say agent is not able to use this open router key, which is very unlikely. Open router is very popular, but insforge also provides us with the example. So this is the Python example or the fast API example, how you can use the open router API key. It's very similar to OpenAI API key. So any agent will be able to do it. I've already pasted this in the .env file. So execution will go flawless. Now let's go back to our IDE. Even our step 3 is complete. Of course, we cannot visualize the AI investigation at this point because we did not integrate all the components. That is something that we are going to do in the last step. But at least we reached to this point at this moment. We built the front end, we built the fast API backend. Fast API backend is performing the Kubernetes investigation. It sends this information to AI agent. AI agent using large language model, that is the open router, it is going to perform the diagnosis for us. So we are good till this moment. What are the pieces that are left? The critical piece, if we go back to our architecture, are InSforge for storing the investigation history and authorization, also showing the real-time status. These things are pending. This is going to be our fourth component that we're going to build. Again, if you go back to the GitHub repository, prompt for InSforge backend prompt. The goal of this prompt or the action that we are asking agent to execute, create minimal dashboard, implement authentication using InSforge, build real-time investigation progress, show the investigation history, maintain it, and establish front-end and back-end integration. When it comes to authentication, add authentication using InSforge. I'm providing the requirement. I need login support. I'm looking for protected dashboard, user session handling. In the investigation dashboard, I'm looking for AI Kubernetes agent investigation, where user should see an option for clicking on the investigate cluster. And in the investigation process, user should see the real-time progress, checking pods, checking logs, analyzing the event. What is the action that is taking place at the moment? And also show the root cause on the user interface. So let me go to the raw mode, copy this entire prompt and paste it on the IDE. This is not going to take a lot of time because our MCP is configured, InSforge MCP. Just for example, you can see here, it is creating a table within the InSforge DB. I'm not providing query to create the table. It's using MCP. Using MCP, it gets the information from InSforge documentation and it creates a query and creates the table within the database. So that's the reason why the implementation becomes fast. As a man in middle, if you're providing the queries that are required, then you have to search for the queries or you have to ask AI for the queries. And every time you have to verify if the relevant information is created within the database. Same is with storage. Same is with authentication and authorization as well. Sounds cool, right? Yes. And also if you see here, in the prompt we asked to integrate front end and back end. During the integration, looks like it wanted to download a template. Now it's not asking us to download the template and provide the template information. Instead, it is just asking us to allow the required MCP server and it has downloaded the template. See, template is downloaded successfully. If you're going with Postgres or any other alternative, you have to manually configure most of these things. So finally, our prompt 4 is also complete. The front-end dashboard plus API integration. Prompt 4 is completed. Here is what we have till now. Sign in InSforge. Okay, so we have authentication part set up. Then user can get to see the dashboard. Click on the investigate cluster. Look at the real-time progress, the information, investigation information, what is the progress and summary, history saved and listed. But for this, you should see the database and tables created. Let's see on the dashboard. Cool. So we have two tables created. If we go to database, one is the investigation process table and one is the investigations table. In this table, we haven't run any investigation till now, but once we run investigations, this will have the investigation history and this will show us the progress of the investigation. This information is fetched from here and shown to the user on the front end. And then it also set up slash sign in on the front end. Okay. So the authentication part is also set up. Slash sign in API helps with login, helps with registration. A 6-digit email verification as well. And it will also show the dashboard on the main user interface. So InSforge has also implemented this for us. Cool. Let's start the backend using Docker Compose and see if everything that we're looking for is in place. So Docker Compose, I'll switch to the folder. In my case, I'm in the downloads folder. The project is here, followed by Kubernetes AI Kubernetes agent. Okay, let me run Docker Compose hyphen build. It has started the containers. Application startup complete. Let's go back to localhost 3000. Previously, when we looked at the localhost 3000, we directly saw the option for investigate cluster because the authentication was not set up. Now let's see. On localhost 3000, I see an option for sign in. Cool. I don't have an account. Let me just click on sign up and create an account. I'll use one of my email addresses. Okay. And let me also set up a password real quick. Click on the sign up. It says network request failed, network error when attempting to fetch resource. Probably there is something missing or there is some issue with front end and back end integration. Not a problem. Let's provide the same error. Looks like it found the issue. So it says identifying the issue. The Docker front end build omits the InSforge environment variables, and it is also working towards fixing this issue for us. Great. So now the issue is fixed. Let's try it again. I'll go back, click on sign up, refresh. Cool. So this time it has created an account for us, but for verification, it sent a 6-digit email code. I got that on my mobile. I'll just enter this here, verify. My bad. There is a typo, 492310. Let's verify. So this is my email ID. Now only authorized users can access the platform. If you implement this within your organization, you can only allow your organizational email IDs, or you can only allow certain email IDs, certain users, certain teams. It's up to you. You just have to add an entry in the database. No previous investigations. Makes sense because we haven't investigated anything yet. Once we run some investigations, then it will fetch the information. Basically, how the previous investigation history is fetched. So the backend would get that information from database. It would go to investigations table. Here, the investigation information would be saved. So the ID, user ID, I mean, the user who triggered the investigation, session ID, what is the root cause, in which namespace, and what is the status. All this information will be pulled from here and displayed to the user on the front end. Nice. Now we are only left with one thing, that is the end-to-end integration. Right now you see an option for investigate cluster, but ideally I should see different Kubernetes clusters, various Kubernetes clusters, part of your organization. In my case, various Kubernetes clusters running on my machine, and I should be able to click on the relevant Kubernetes cluster and perform the integration. Even at this moment, the Kubernetes cluster is not connected to the platform. So for that, we will execute our final prompt, the end-to-end investigation prompt or end-to-end integration prompt. What is this going to do? Goal, integrate everything end-to-end. Test real Kubernetes failures. Improve the reliability. And I've also provided the end-to-end user workflow here. I've provided how to get the Kubernetes cluster information. So I'm telling it to get the Kubernetes clusters from my local machine. If you're doing it within your organization, you can say get the information from a kubeconfig or from the OAuth, SSO, whatever is the feasible option for you. Let me go to the raw mode, copy this entire prompt and paste it on the IDE. Now this will set up the complete integration for us. This might take another 2 to 3 minutes. We can track the things in the meanwhile. So a new feature is created, the cluster selection feature. From kubeconfig, it will fetch the list of clusters on my local machine. In your case, as I told you, you can go with a different option if you're doing this within your organization. And then it also improved the reliability of the front end as well as back end. Cool, it is all done. Now I just have to run Docker Compose up hyphen build. So all the components are rebuilt. Let's go back to the terminal. First, I'll run Docker Compose down so that the existing containers are destroyed. Now I'll run Docker Compose up hyphen build. Great. So application startup is complete. The AI Kubernetes agent, the troubleshooting agent is running all good. Let's see. I'll go to the browser. I'll access localhost 3000 again. There we go. So now this is the authenticated user. These are the list of clusters. I can select a cluster and click on investigate the cluster. But I really don't like the user interface that much. Let's ask the cursor to enhance the user interface. The backend part looks good. The database related configuration also looks good, but only the user interface can be much better. It should not take much time. In less than a minute, we should have this user interface beautified. I'll just go back to the IDE and I'll provide it with a prompt. Beautify the user interface. Do not change any features because the features are all good. Now the execution is complete. UI is updated with cohesive visual design. No features or behavior were changed. These are the changes to the UI. Let's see by rebuilding the front end. This time we just have to rebuild the front end. So I'll just go back or let me restart everything. It wouldn't take more than 30 seconds. Restart is complete. Application startup is also complete. Let's try again. So I'll try to access localhost 3000 one more time. This time I hope user interface would be better as expected. So now the signed in user gets a display picture, better user experience. Also the clusters are in the tiles form. I can easily navigate through the cluster. I can read the names of the clusters. I can select the cluster and click on investigate. Also, this is the place where previous investigations are shown. So definitely much better than the previous user experience. Let me click on the demo Kubernetes cluster, the one that we created at the beginning of the video, and click on investigate cluster. Right now, I haven't deployed anything to it. Only the default resources are in it. So I hope there will not be any issues with the cluster. Let's see. Investigating Kubernetes cluster, checking pods. There you go. So it is checking the pods, it is reading the logs, it is analyzing the events, inspecting the deployments, checking the networking, AI reasoning. So this will take time because all of this information should be sent through Open Router to the relevant large language model. Open Router picks up the best one and it also found the root cause. Fine, it says there is one issue, root cause, core DNS pods are failing because of readiness probes. This is expected because we are using kind cluster, but other than that, there is no other issue on the cluster. This is totally fine. We can ignore this. But now we are confident that our AI Kubernetes troubleshooting agent is working as expected. If we go to the Infoj backend and go back to the dashboard, now on the project, I'll go to the databases. So in the databases section, I'll pick up the table. So these are databases, investigations. So this is the past investigation. You can clearly see core DNS pods are failing. And this will be reflected even in the investigation history. Let me refresh. Okay. Now if I scroll down, recent investigations. If you want, you can move this to a different HTML page as well. That's not a big deal. You can either have it here or just move to a different page or different view, anything that you like. Now let's take the next step. Let's deploy an Nginx pod onto the Kubernetes cluster. And the Nginx pod we will deploy in a way it goes to the crash loop backup state. And let's see if our Kubernetes troubleshooting agent will it identify the Nginx crash loop backup issue, right? Let's do that. So I'll go to the Kubernetes cluster. I'll deploy Nginx pod using kubectl run Nginx crash. This is the deployment name. The image is Nginx latest, but in the command, I'm just passing exit one so that Nginx container within the pod goes to the crash loop backup state. Perfect. Let's see. Okay, Nginx crash is created. Let's verify from here. kubectl get pods. Container is creating. It is yet to create the container, and then it has to run this command exit one. Only then the container goes down and pod goes into crash loop backup. Let's see. Okay, it moved to error status. In a while, it will also go to the crash loop backup. Perfect. Let's go here. Let's refresh this. Now let's run investigation on the cluster. Now this is going to be interesting. This is where we are going to test our Kubernetes troubleshooting agent. It has checked the pods. Probably by this time, it should have understood the Nginx related issue. It sent the information for AI reasoning through Open Router. Root cause found. There you go. Nginx crash. Pod failed due to the node being rebooted, causing a loss of state and subsequent pod failures. kubectl command, run this command for deleting the pod. And you can see here it says 75%. So AI is not 100% confident about it. What AI did here, it explained the issue for us. So this is the root cause. This is the explanation why Nginx pod is in the crash loop backup state or in the error state. Suggested fix, investigate the node's reboot cause, and then ensure the node is stable. Obviously, this is not going to fix the issue for us. That's why 75% is only the success rate, or 75% is the confidence. When AI is 100% confident about the issue, then you would see 100% rate here. It depends on a lot of things. Now, Open Router might have used a specific model because we haven't hard coded the model. Let's say you go with the Claude Opus 4.7, which is a very high reasoning model. You can hard code that within your application, the agent application. Then you might see the success rate as 70%, 80%, 90%. It depends on that. Anyways, what we are trying to build is built successfully. Now let's also try it one more time. This time let's look at the end-to-end workflow. Right from sign up, we will create an issue on the cluster. Then using this agent application that we built, let's see if the workflow is working fine. So this is our AI Kubernetes troubleshooting agent. We already created an account. So let me quickly sign into it. So this is a signed in user and it has a list of clusters. These are all the clusters that I have access to, almost 14 Kubernetes clusters. I'll select one of the cluster and click on the investigate cluster. It will show the current status of the cluster and any issues on the cluster. Now intentionally, let's create an issue on this cluster. So I'll go to my terminal. I'll deploy an Nginx pod. This is an Nginx pod that has an invalid image. kubectl run Nginx image pull back off. This tag does not exist. So basically, when you run this, a pod will be created and the status of pod would be image pull back off. There you see error image pull and the next status would be image pull back off. Perfect. Now we should see this. Let's say there is a developer finding it difficult to understand what went wrong with the cluster or what went wrong with the pod. They can come here, click on it and click on investigate the cluster. If they have access to the cluster right now, this is using my kubeconfig file. So I have access to it. What is it doing? It is investigating, checking the pods, reading the logs, analyzing the events, inspecting the deployments, checking the networking, giving this entire information to AI. Basically, we are using Open Router here and root cause found. You can see it perform the root cause. What does it say? The pod Nginx image pull backoff is in pending state due to an image pull error on non-existing image tag. It exactly explained you the issue. This is the image that you're using, and this image is invalid image. Just use the valid image, something like Nginx latest. It also gave the kubectl command. This is the confidence score. AI is confident that the command is 80% correct, or the investigation is 80% correct. There is a reason for it. Why is it not 100%? Because there is a possibility you might not want to use this image. Maybe your organization wants to use a different image. And it also says, how do you prevent these issues in the future? Probably use the CI/CD checks. On top of that, we also have the recent investigations. Till now, we did 3 different investigations, and all of the information is stored here. Where are we getting this from? We are getting this from the InfoJ database that we configured. And this is also automatically configured. We have investigations table and we have investigation progress. All the previous investigations progress is here, the different steps that were performed. And these are the different investigations. First issue was because of core DNS. Second issue was because of Nginx crash, the crash loop backoff. And the recent one is because of Nginx image pull backoff. The same information is shown here. If you want, as I told you, you can make a cool addition. Probably you can move this diagnosis information, the recent investigations information to different pages or different views on the platform. This is exactly according to the user workflow that we have in the README file. In the README file, this is the workflow that we wanted, and we got the same end-to-end workflow. Perfect. So I hope you found the video insightful. So this is how you build an AI Kubernetes agent using Python and InSports. Once again, all the useful links are in the description as well as the pinned comment. You can also take a look at the GitHub repository. Let's say you want to understand more about architecture or the prompts that are used in the video. If you have any questions, do let me know in the comment section. I'm more than happy to help. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. AI Cloud Cost Detective. Yes, we are going to build an AI Cloud Cost Detective in today's video. Just imagine this. You have an AI utility, you build that on your own. It connects to your cloud platform, looks at the resources on the cloud, looks at the configuration of the resources, and instantly tells you how you can modify those resources to bring your cloud cost significantly down. A lot of times you misconfigure the resources or you over provision the resources, but this utility can tell you what changes you can make and bring down the cloud cost. Wouldn't that be awesome? Now you might say, but Abhishek, there are some open source projects like Carpenter. Yes, these projects are good, but they are restricted to certain cloud services. For example, Carpenter works well with Kubernetes clusters. But with the help of AI, what we are going to build today is something that works with most of the cloud services. And it works with your virtual machines, it works with your S3 buckets, Kubernetes clusters, databases, volumes, anything. Most importantly, you are building this on your own. Let's say there is an open source project tomorrow, but still, because you made it on your own, tomorrow if there is a requirement within your organization, you just provide a prompt, modify the tool accordingly, and it is ready in minutes, right? By the end of this video, I will make sure you have everything that is needed. And after watching the video, you can go back and build this by your own. Just like any other project on the channel, I've created a GitHub repository for this as well. The GitHub repository has architecture diagram, it has the request flow, and most importantly, the prompts that we are going to use in building the project. We will do this in 5 simple steps, right? Just to make sure everyone understands the project clearly. I'll break down this into 5 steps. First step, problem statement. I'll explain you what is the requirement, why are we building this project, what problem are we solving. Second, I'll explain the tooling that we are going to use. What tools are we going to use to build this project? We are mostly going to use open source tools. Then I'll walk you through the architecture diagram, a detailed architecture diagram, so that you understand how each component is connected to other. Fourth, I'll walk you through the request flow so that you understand how a user's request flows within the platform. Finally, implementation. Then I'll head to my AI coding tool. I'll start building this application. You can use your GitHub Copilot, you can use Claude Code, you can use Cursor, anything that you have access to. End of the video, as I told you, you will be building the project. Perfect. Now, without any delay, let's get started. Let's start with the problem statement. Abhishek, why are we building this AI cloud cost detective? Is it really important? Very valid question. Let me explain. Majority of the organizations today, it can be startups, it can be mid-scale companies, large-scale organizations. They are deploying their workloads on the cloud platforms today. From containers to virtual machines to S3 buckets, databases, volumes, everything is on cloud today. Cloud is definitely good. There are so many advantages of cloud. Cloud is very reliable, it's durable, and most importantly, cloud resources can reduce the management for you. But on the downside, there is also a downside. If the cloud resources are not provisioned well, it can significantly cost your organization. Unfortunately, this is what is happening with majority of the organizations today. They expect their cloud billing to be, let's say, 20,000 US dollars by the end of the month. But what they see is 50,000 US dollars. Why is this happening? Maybe the junior DevOps engineer has misconfigured the cloud resources, maybe did not follow the best cost optimization practices, or maybe the junior DevOps engineer has over provisioned the cloud resources, provisioned more than required. End of the day, it will cost a lot for your organization. Abhishek, what organizations do today? They can't do much. They just pay to the cloud platform, whatever the cloud platform is charging them. They pay to the cloud platform. And as an afterthought, maybe end of the quarter, end of the year, they just go to the DevOps team. They ask the DevOps team to prepare a report, which is usually called Cloud Visibility Report. And in the report, they want to see which team is responsible for how much cloud cost in the organization. And maybe as a future project, they will introduce cloud cost optimization. This is what happens in majority of the companies today. Now, is it good? Kind of good because at least they are taking afterthought measurements. They are getting the report, and in future, they have steps to optimize the cloud cost. So it's kind of good. But what we will build today is an AI tool that will not act as an afterthought, but it can prevent organizations from huge cloud costing. Instead of waiting till the end of the month and paying that 50,000 US dollars, using this AI tool that we are going to build, organizations can reduce that to maybe 30,000 US dollars or maybe even 20,000 US dollars as per their expectation. Sounds good, right? Abhishek, how is this going to work? I'll just give you some very high level information now because we anyways are going to talk about architecture in step 3. But how this works, the AI tool that we're going to build, it connects to the cloud platform. In today's video, we will use Azure Cloud. A lot of you are asking for Azure, so I decided to go with Azure Cloud in the video. But it doesn't matter if you want to use the same project for GCP or AWS, it works as is. Only in the prompts that you're using, change Azure to AWS or GCP. You don't have to change anything else. So your AI platform connects to the cloud platform. It looks at the resources, all the resources within a resource group. It gets the configuration of the resources because it is AI, large language models. It gets the information of the best practices. So it compares your existing configuration with the best practices configuration. And then it provides you a detailed summary. Like for S3 buckets, this is a change that you can make. For virtual machines, this is the change that you can make. In fact, it can also provide you some commands if you need. So this will act as a prevention mechanism. And this is how it is going to work. We will make it enterprise grade. We will add authentication to it. We will add storage to it. We will add a very good database to it so that you can also see the investigation history. Perfect. So I hope at this step, problem statement is clear. So the problem is that companies are paying a lot to the cloud today because of misconfiguration or over provisioning the resources. Our AI cloud cost detector can prevent this by connecting to the cloud, by fetching the resources, by fetching the configuration and comparing the configuration with the best configuration from the Azure documentation or from other resources on the cloud. It can also suggest the changes that the DevOps engineers need to make. Cool. Now, before going to the architecture, let me quickly talk about the tool set. I know a lot of you are interested in this because you want to understand, can I actually build this project or not? You can build it. For front end, we are going to build a full stack application, an agent application that has front end, back end, database, everything using AI. For front end, we will use React. React is user friendly. Users can get to the platform. They can use it in a very easy way if we build it using React. Then for the backend or for the programming language, we will use Fast API. Fast API is basically Python. So using Fast API, we will fetch the resources from Azure. Then for the database, we will go with Postgres database. Postgres is very popular open source database and it also comes for very less pricing. So we will go with Postgres in the video. In one of our previous projects, we used InsForge. If you want, you can try InsForge as well. That is also good. Then for the authentication, we want this platform to be enterprise ready. So we want to implement authentication as well. Even for authentication, we will go with Postgres. So we will store user information in Postgres. And then we need model gateway. What is model gateway? We have to send, like, backend collects the information of Azure resources. We have to send that Azure resources to, let's say, to large language models. So we will be using OpenAI in this case. Don't worry. If you're confused at this point, wait for the architecture. Once we head to the architecture, everything will be clear. That's it. These are the tools that we are going to use. Of course, for cloud, I'm using Azure. And for fetching the Azure resources, that is for the data, I'm going to use Azure CLI. Abhishek, why not go with Azure APIs? You can go with Azure APIs as well. But the problem with the APIs is that APIs keep changing. You have to make sure you're using the right version. You are using the right input to the APIs because it keeps changing. Down the line, your maintenance with the application that you're building will also be more. We want to keep the maintenance low. So that's why I'll go with Azure CLI. So this is the tool set that we are going to use in the video. Now let's get to the interesting part, architecture. Abhishek, explain the detailed architecture of the project that we are going to build. Why not? Let's talk about it. Firstly, users. Who are the users? It can be developers, DevOps engineers, or your management. Anyone who wants to use this platform, they will just head to the user interface of the platform, or we can say they will head to the front end of the platform. Within the front end, the first thing that they see, they will not see connection to Azure, but they will first see the authentication. We don't want everyone to use the platform. We want to restrict who can use the platform. Maybe a junior developer should not use it, or maybe a junior tester should not use it. Someone in the operations team, maybe they should not use it. So we will restrict the authentication to it. Once the authentication is successful, let's say the authentication is successful, then user would see an option to provide the Azure resource group. So either they can select the Azure resource group from the user interface, or they will provide the ID of the Azure resource group. Now, once this is provided, this is the key part. This is where our backend comes into picture. That is, our Python comes into picture. What our backend does? Backend connects to the Azure CLI. It will make use of Azure CLI, and making the use of Azure CLI, it will fetch the resources from the cloud. What all resources are available in the Azure resource group. And once the information is fetched, it has to fetch a lot of information. So we will use multiple Azure CLI commands here. Good part about the CLI commands, over the period of time, they don't change. If you look at Azure CLI command for fetching virtual machines today and maybe 3 years before, the command is almost the same, because CLI always maintains the compatibility. 99%. I cannot say 100%. Okay, once this resources is fetched, because this is huge information, this is sent to AI. This is where we are going to use OpenAI API key. If you want to reduce the cost, you can also go with Open Router API key. But I already have OpenAI API key, so I'll go with it. It doesn't matter. If you have Anthropic API key, go with it. If you have Open Router API key, go with it. What AI does, it performs the analysis, right? The critical part of our entire architecture. AI performs the analysis. AI looks at all the cloud resources. It looks at the best configuration for those cloud resources. And once the analysis is done, it provides us with a summary. Like, it tells the user, hey, these are the steps that you could have done better. You have configured Kubernetes cluster with 6 nodes. Probably you only need 3 nodes. You have created virtual machines with a particular instance type. You don't need that instance type. Probably you can go with a lesser instance type. And along with the summary, it can also provide the steps. And this is shown to the user back on the front end or on the user interface. Again, the same path. Information is stored within the database. This analysis is stored within the database, where we are using the Postgres database. And from the database, backend fetches the information and shows it back to the user. This is what happens end to end in the application agent that we are going to build, or the agent application that we are going to build. Let me quickly explain this one more time. This is the important part. Please try to understand. First, users talk to the front end. Front end, users cannot connect to the cluster or to their Azure cloud platform. There is an authentication in place. We are using Postgres for this authentication. If the user is authenticated, user can provide the resource group. This resource group, name of the resource group is taken by the backend, where we are using Python or Fast API. Backend makes use of Azure CLI. It connects to the Azure cloud platform, and it will fetch information from the Azure cloud platform. This information is sent to AI, where I'm using OpenAI API key. But if you want, you can go with Open Router API key as well. Then this information is sent to analysis. This entire analysis is summarized and shown back to the user. But to keep the history of the information, to keep the history of the investigation, maybe I ran this investigation on 29th of May. Someone else also want to see it instead of running it again. If the platform provides investigation history, they can just go to the history board, or they can just go to the previous investigation and see what has happened. So they don't have to run this entire thing again. And yeah, you can find the same information in our GitHub repository as well. If you head to the README file, you will find architecture section, where you can find the same thing that I explained on the whiteboard, probably little more detailed. Along with that, you can also find request flow section. Abhishek, why do I have to write this in the README file? There is an advantage. See, when we are planning to build an application using AI assistants, it can be Cursor, it can be GitHub Copilot, Claude Code, or even OpenClaw with local models, I mean using Olama, when you provide architecture diagram and when you provide request flow, there are chances it can build your application in the very first run. When you provide prompts, of course, I'll walk you through the prompts. We are going to provide very detailed prompts as well, but still there is a chance that your AI coding assistant might get your requirement wrong. But when you put the information in this way, in the architecture diagram, in the request flow, there are very less chances that it can go wrong. That's why I've documented this information in the GitHub repository. Perfect. So now we understood the problem statement. We understood the tool stack, the tech stack that we are going to use. We are clear with the architecture diagram. We are also clear with the request flow. So what's next? The next step is implementation. But before we implement, there are two prerequisites in this case. One, you need an Azure account. In my case, I've created an account and I've created two resource groups here. Let me increase the font. So you can see this is my Azure account. I've created two accounts here. I mean, two resource groups here. The payments resource group where I have bunch of resources in here. For example, in the payments resource group, I have a Nginx virtual machine. Then I have networking related to the Nginx virtual machine. I have some premium disk. I have orphan data disk. Along with that, I also have a storage account. Similarly, even in other resource group, I have created bunch of resources. If you look at the middleware resource group, I've created storage account here as well. I've created a bunch of virtual machines, the networking of the virtual machine, and I've created some orphan disks, basically some disks that are not used by the virtual machines. So our Azure account is ready. You can also set up something like this. You can ask, let's say you're using AWS, you can ask ChatGPT to give you some AWS CLI commands and create some infrastructure on AWS. Or if you have expertise, go ahead, create some resources, create some Kubernetes clusters, make your cloud platform ready. Because end of the day, we want to play with the cloud environment. AI cloud cost detective, it works better when you have more resources on the cloud. Only then it gets the opportunity to look at the resource configuration, see what you have configured wrong, and then it can detect and give you the suggestions. Perfect. So our Azure cloud environment in my case is ready. Now the second thing, we need OpenAI API key. Even I have that thing ready as well. I use OpenAI API key, so I have it ready. All that you have to do, like let's say you want to use OpenAI API key, you have to get to platform.openai.com. Then you have to get to the API keys. Click here, create a new secret API key, provide a name. I'll say, let's say, let me call it Detective. Choose the default project or you can create a project. Then click on create secret key. Once you have this key, copy it and paste this key within the .env file of the project. Basically, you can clone this GitHub repository. Within this GitHub repository, you can create a .env file and paste your OpenAI key there. Perfect. I'll create a dummy.env file here so that you understand where exactly to copy the OpenAI API key. Abhishek, I don't have OpenAI API key. It's okay. You can go with Anthropic API key or OpenRouter API key, which is much cheaper. In the previous project, I used OpenRouter API key. That's why this time I'm using OpenAI API key. That's it. There is no other specific criteria. Cool. So both our prerequisites are also ready. Now let's head to cursor. Cool. So I have a cursor subscription, so I'll be using it. I'll go to the agent section and I will start with the first prompt here. I've cloned the repository. I've created .env file. As I told you, this has my OpenAI secret. I'll start with the very first prompt. Go to the GitHub repository. Can you guess what will be the first prompt? The first prompt is to create the Python backend. right? What is the core piece of our entire architecture? If you look at this entire architecture, the core piece is the Python backend. So Python backend will take the resource group as input. Then it will make use of Azure CLI. It will fetch the resources from the Azure cloud. So if you get this piece working, right? If you can get this piece working, then rest of the things are little easier. Okay, let me show you how I wrote this prompt. So first of all, I explained create a Python fast API backend in backend folder. So I'm asking it to create a folder in the cloud cost detective project. Okay, that's fine. A fast API server with post slash analyze input endpoint that accepts resource group. So this is what I told you. The Python backend should basically accept resource group as input. User will provide this information from the front end. Then I said get slash API resource group endpoint that returns list of Azure resource groups. Okay, this is fine. Then use the Python subprocess module to run Azure CLI commands. You understood why I wrote this here in the prompt? Because we want to use Azure CLI. If you don't put these lines here, from here to here, if you don't put these lines in the prompt, by default, your AI coding assistant, that is cursor, would go with Azure APIs. And Azure APIs can constantly change. Maybe 2 months down the line, somebody will report that your project is not working. CLI is more compatible. Then the basic things like enable cores, include requirements.txt, and this has to be the structure of it. This is the line that plays the critical role. Abhishek, why did you add architecture.md and requestflow.md? I just explained. Even in the prompt, I'm explaining within the prompt, refer to architecture.md and requestflow.md. This is why I added these MD files. Imagine if I don't provide this, and if I provide this entire prompt, there is 10 to 20% chance that it might create the Python backend for you, but not as per your requirement. When you provide this, then your chances of efficiency will increase by 10 to 15%. Cool. Okay. So I'll take the raw mode. I'll copy this entire prompt and paste it on the cursor. I'm using Opus 4.6 high. If you want, you can switch the model. Composer 2.5 is also good enough. It will consume less amount of tokens. Let me switch to that. Okay. Now I'll provide this prompt and wait for 2 to 3 minutes because this is going to take time. It has to install Python, then it has to download the required dependencies. It has to find Azure CLI on my machine. So let's wait for 2 to 3 minutes here. Nice. So this is the, in fact, it took less than 2 minutes. It created the backend where it created main.py, Azure scanner.py. It also created cost detector.py. Let me quickly walk you through these files. Main.py, the primary entry point. Then you have the cost detector.py. This is the actual file, I mean the core file. So what it does, it lists out the resources and things that are cloud cost detector is looking at or detecting. What are the things that it is detecting? One, oversized virtual machines. So it is trying to see if there are any Azure virtual machines on your cloud platform that are oversized or over provisioned. Maybe requirement is only 2 CPU, but it is created with 5 CPU. Orphan disks that are not connected to the virtual machines. Stale hot blobs. Blobs are, I mean, if you are aware of Azure, blobs are like S3. Geo redundant storage. Redundant storage accounts. Unused static public IPs. Wow, this is something that even I did not expect. Probably if I'm writing something like this, I wouldn't have thought of unused static public IPs. This is a good one. Why? Because a lot of times you create public IPs, especially if you're working on enterprise, and sometimes you delete the virtual machine or you move to Kubernetes. You forget about that public IP that you have created. Of course, it does not charge a lot, but still in AWS, Azure, and GCP, elastic IPs or the static IPs, they are charged. So even the one that we're building, is looking at any stale or unused static public IPs. Load balancers without backend, good. Permissive NSGs, oversized OSDs, same thing, like just like oversized virtual machines, oversized disks. Unused file shares. Like file shares are like EFS on AWS. Abhishek, what if I want to add more? Okay, these are 10 good things, but I want something like app services. No worries. The logic is here. What you have to do, just create a new line. Oh, it also, I mean, the AI also picked up app services. Very surprising. But, anyways, like if you want to add app services, just add the flag here, then follow the implementation. For example, you can just follow this particular implementation, detect permissive NSGs, see how is this function written or definition written. You can add the same thing for app services as well. Abhishek, I'm not good at Python. Then don't add this flag. Instead, just head to cursor and add a prompt here. Enhance the agent application to also detect stale app services, right? Or issues with the app services. Similarly, if you want to add storage accounts or anything more, you can go ahead and do it. It's that simple. And this is the flexibility I was talking about. If you go with an open source project, if you're looking for a feature, they might not have it. And if you want them to add the feature, you have to create a support ticket, you have to wait for them. But in this case, you can add any feature in matter of minutes. And the complete control is with you. Good. Okay. Then in the Azure scanner, I think you might guess it. What is this doing? This is the file that is connecting to your Azure console using Azure CLI, and it is getting the resources. Basically, this is getting the resources on the Azure cloud platform, and the cost detector is trying to detect some information. But end of the day, okay, this is the complete Python backend, but end of the day, without AI, analysis is incomplete. Now let's add the analysis part. How do we add the analysis part? Go back to the repo. In the repo, just go back to the prompts folder. You will find OpenAI analysis. Go to that. OpenAI API integration for cost analysis. Build on top of existing fast API backend. By the time you're running prompt 2, the prompt 1 has created the fast API backend. So that's why build on top of existing fast API backend. Add AI powered cost analysis using OpenAPI directly. Create AI analyzer.py module. Take the list of Azure resources that we get from Azure scanner.py. As I explained you here, Azure scanner.py gets the resources within the resource group. Now AI will scan those resources. Build the prompt asking AI to analyze the resources for over provisioning. Yeah, the same thing. Whatever we have in the detection file, detect.py. Call the OpenAI chat. We are asking it to use the GPT-4o model. If you want, you can go with GPT 5.5 or any other model. In fact, you can ask it to use the different models, so OSS GPT model as well, depending upon the tokens that you want to consume. Then the basic information. Again, even if you look at the prompt 2, end of the prompt 2, I've provided the same thing. Refer to architecture.md and request flow.md. If you look at any file, you will find, any prompt, you will look at this line at the end. That's the reason why the efficiency is more in my case. In the very first prompt, cursor was able to generate the backend as per my expectation because of this line. The same thing will happen with prompt 2 as well. Okay. Now let's go back to cursor. Either we can create a new agent or we can continue with the existing one. Anything works. Okay. I'll close these agents. I'll click on a new agent, and here I'll say just paste the prompt. Now this is also going to take another 2 to 3 minutes. This time it has to just collect my or understand where is my OpenAI key, the API key. Then it has to frame the prompt. Once it is ready, I'll walk you through the Python file as well. This is also done. So I can see AI analyzer.py is created for us. This is getting the information, the resource group information. It is creating a system prompt and it's sending the resources to the GPT-4o model as expected because we provided GPT-4o in the prompt. If you want to change, change here. So till now, what did we implement? We created the fast API backend. So fast API backend takes the resource group name. It detects the resources using detect cost flags, the 10 flags that I shown you. It sends the information for to the OpenAI models for analysis. This is what we implemented till now. What are the missing pieces? Let's go back to our architecture. So here we implemented these things, the backend, we implemented OpenAI analysis. Before we head to the front end, before we head to the end-to-end integration, one piece that's left, the Postgres implementation. Postgres in this case is performing very interesting things for us. First, see, we don't want users to run this platform very often. Like, let's say we hosted this AI cloud cost detective. 5 o'clock, someone provided a resource group and they got the information. Then 5:15, if other person runs for the same resource group, what's the point? Nothing is going to change in 15 minutes or nothing is going to change in 1 hour of time. But this will only waste AI tokens for your organization or AI is going to charge your organization. So what we will do instead of this, we will maintain the database which stores investigation history or it will store the past detections. So at 5:15, if someone wants to run, they can just go to the history, see if someone executed it today for a specific resource group. If they have executed the detection for the specific resource group today, they can just view at the history. Along with that, whenever user runs the cloud cost detective, they should see the real-time progress, right? For example, this is taking 2 minutes of time. You should show something on the screen that it is currently detecting virtual machines, currently detecting stale blobs, currently detecting the static IPs. So user has to see some progress on the dashboard, on the user interface. And finally, authentication. Authentication as well as authorization. This is also important. Right now, we will only implement authentication. All these three things will be done by Postgres. So this is the prompt for Postgres. If you go to prompt 3, Azure Postgres WebSocket.md. Let's see what is in it. Build on top of existing fast API backend, the same thing, whatever we have till now. Add Azure managed Postgres for storing user analyzing history and fast API WebSocket for live progress updates. Same thing I just explained. But we are using Azure managed Postgres service. What is the database to use? I mean, I'm providing little more information. Go for Azure managed Postgres, connect to this. Then I'm asking it to store the DB connection string in .env, where I'm already storing OpenAI API key. Then I'm asking it to create two tables. I'm providing the table information. Abhishek, in the last project, we did not provide table information. We did not provide database schema. Why are we doing it in this project? So if you remember, in the last project, we used InsForge. InsForge is basically AI native backend, but Postgres is not designed as an AI native backend. So we have to provide more information here. That is what I'm doing here. And also I'm explaining in terms of real-time progress. I'm telling AI, I should see something like this. When user runs my cloud cost detective, they should see what is the current status. For example, fetching resource group, scanning resources, analyzing cost, storing results. If it is going to take 2 minutes, user is engaged in the meanwhile. And user knows that my agent application is not stuck. Just provided an example of .env.example and finally refer to architecture.md and request flow.md. Let's go to the raw mode. I'll copy this entire thing and I will paste it here. Okay. Now let me just put that information here. As expected, it took little more time, but you can see prompt 3 implementation is also complete. It created a db.py file, progress.py, and auth.py file, individual Python files. In the db.py, you can see there is a table. This is the analysis table. This is the users table, and the logic to connect to the database, the Postgres database. The Postgres connection string is as part of the .env .example file or the .env file. Okay, so this part is also complete. So we have our Postgres database also set up. So all this information is complete. Now we are only left with front-end implementation and front-end connection with the backend. So two different prompts. In the first prompt, we will create front-end. Let's see if we like the front-end, we will use it. In the first go, if it does not develop the front-end well, if you're going with AI agents like Lovable or other solutions, you can be rest assured front end will look good. But because we are going with cursor, I doubt in the first go, if the front end is good, we'll use it. Or otherwise, we will modify the front end. And in the next prompt, we will establish the connection between front end and back end. That will complete our agent application. Let's do that. So we will go to prompt 4. So prompt 4 is to create React frontend. Okay. Create the React frontend in the frontend folder, just like the backend folder, and make use of JWT. As we discussed, right? Authentication will be implemented using Postgres, and that will be using Java Web Tokens. And here we are saying setup using White. White is the server for running frontend, React, and TypeScript. For CSS, we are asking it to use the Tailwind. Authentication, specifically using custom Java Web Tokens. I provided little information on how to use the authentication. For encryption, I mean the endpoints for authentication like sign up page, login page. And for encryption, I'm asking it to use bcrypt. And these are the different pages on the front end, like the login page, dashboard page, analysis report, and the history. Whatever we discussed. These are the 4 pages on the front end. If you want, you can modify it. Like if you feel like, Abhishek, I want everything in one single page. I don't like the multi pages. Then you can change it, like put everything under one page. It's up to you. And finally, refer to the architecture.md. Cool. Let me copy this and paste it in the cursor. Front end will not take a lot of time. Probably in 2 minutes, we should have the front end developed for this application. Let's see. Once it is done, we will track the progress. So the front end is also complete. You can see JWT is also set up. I mean, authentication is also complete. But I doubt it will work at this point because although we created the front end for AWT to work, I mean JWT to work, the Java Web Tokens and authentication, it needs a connection with the Postgres database. So we still have to implement front end integration with backend. So my bad, it might not work. I mean, front end is created, I'm sure, but front end will not be able to connect to the database at this moment. So let's also go ahead and run our prompt 5. Integrate front end and back end. We cannot review front end at this point. So let's complete this. Integrate front end and back end, basically end to end. What are we saying here? Connect React front end with fast API backend, wire up WebSocket for live progress, authentication for all the routes, and display the history. More information here, like the API integration information, WebSocket, history information, and I'm also asking it to perform a final test so that we don't have to go see something is wrong. Instead, it can perform the final test and say if everything is looking good. Cool. So let me run this. And once this is complete, then instead of just reviewing the front end, let's review the end-to-end application. Cool. And again, this is a very simple thing because for front end and back end integration, it just has to use an existing SDK. And with the SDK, it will wire up the things. Postgres database is already available. Looks like it is done. I can also see on the terminal. So there are 2 terminals. I can see the Wheat server is running. I hope it is done. Let's see. So we'll go back to the same thing. I'll provide again the same email address. Let me provide the password for it. Okay, now we have the front end. Front end looks very minimalistic. Here is the email address, logout option, dashboard. It also has the history. And on the dashboard, it provides a toggle button where I can, or drop down where I can see different resource groups. Same thing on my Azure cloud. Right now, I just have three resource groups. Let's select one of the resource group. We will go with the payments resource group and see. I'll quickly run the analysis. Okay. WebSocket connection failed. Ensure that the backend is running on port 8000. Is the backend running? Oh, no. Okay. So we can clearly see here, we'll resume when background work finishes. Looks like there is some issue with backend. Even here, I can see the error. We'll just paste this error. We don't have to debug this. I'll paste it here, or the error that I have here on run analysis. Let's see if AI is going to fix this for me. I hope it should be a straightforward issue. It fixed the issue for us. It says the API is now running at 8000. Let's see. One more time, we will test it. I'll refresh. I'll select the resource group again. Payments Aqua, run analysis. Perfect. So it started running the analysis. Analysis is in progress. Fetching the resource groups, scanning the resources, analyzing the cost with AI, storing the results, and analysis is complete. So these are the things at the moment. Okay, it took like 10-15 seconds, but I can see this is the analysis report. It shared the resource group. Resources scanned are 10. Issues found are 6. Estimated monthly savings is 200 to 500 US dollars. See, this is a big thing. I just created 10 resources on my Azure cloud. It scanned the 10 resources. It figured out there are 6 issues. It provided a summary as well. The payments acquire resource group has several high severity cost issues, including oversized VMs, orphan disks, and multiple things. Here is the summary of each issue, and you can see there is a command and there is estimated saving as well. So here, this is the first one, oversized virtual machine, which is on payments Nginx virtual machine. It is saying right now we are using standard D4 AS V7. Payments Nginx virtual machine runs on, okay, this one with 4 vCPUs, but appears suited to a lightweight workload, Nginx Simple API and web proxy. So just for Nginx and Simple API, we created 4 CPUs. It is saying you don't need it. You can just go with standard B2S. Let's see if it is true. So I'll go to my Azure Cloud Platform. Let me put this here. Okay. Let's see what it is saying is true. I'll go to Payments Aqua resource group. I will go to the virtual machine that is talking about Payments Nginx VM. Payments Nginx VM. Okay, this is the one. What is the configuration of it? So its current configuration is D4 AS V7, exactly what it mentioned. And it says we are underutilizing the resources. Let's see. I'll go to monitor. What is the CPU utilization? Oh, yes. So you can see the CPU utilization is very, very less. Percentage of CPU that is used. And even the memory utilization is very less. So that's why it recommended us to move to standard B2S. I think this comes with 1 CPU. Perfect. Very good option. Very good cloud detection, the cost detection. Then it says orphan disk. Even with payments orphaned disk 2, you are going with premium LRS. But it says you can just go with data disk 2. You don't have to go with the premium tier. And here you can save 20 to 50 US dollars. Let's see again if it is true. Payments orphaned disk 2. I'll go back. In the same resource group, I should see payments orphaned disk 2. Okay, this is the one. And it is using the tier. Let's look at the tier. Premium SSD LRS. What it mentioned is true. It is of size 256 GB, but our utilization is almost 0. So it is saying you don't need this premium LRS. Very good. Again, a good suggestion. Similarly, It talks about unused static public IP addresses. It says you have this static public IP address, payments unused PIP. You can just remove it. Okay. And this will save $5 per month. Overlay permissive NSG, and it also provided this is high severity, this is medium severity. Additional resources, it also provided some additional resources that we can go through. So our analysis report and our AI cloud cost detective is working as expected. And I'm happy with the user interface as well. I thought cursor will be generating something which does not look good. It happened to us last time, but this time it generated pretty well. And I'm happy with it. Now let's see one overall like end to end, because we tested this functionality in multiple levels and we gave it multiple prompts. Now that our agent application is ready, let's view it in one end to end go. I will sign out of this application and now let's see end to end flow. So on my Azure cloud platform, I have two resource groups, and in each resource group, I created multiple resources, which would cost me around 50,000 rupees. But most of these resources are misconfigured. I mean, these resources are configured in cost inoptimized way. Most of these resources are over provisioned. Let's see, we build this AI cloud cost detective. If it will detect the over provisioned resources and it will help us in saving the money. So I just signed in. This is the cloud cost detective dashboard. It already looked at different resource groups I have. It figured out. I'll select one resource group, click on run analysis. It is fetching the resource group information. It is scanning the resources. It is analyzing the cost with AI. It is storing the results in the Postgres database. And finally, the analysis is complete. It will provide us with the detailed report. This is the analysis report. So it says we have 10 resources in the resource group. It found 6 issues and it can save 200 to 500 US dollars just if we follow the steps that it provided. First of all, it identified the virtual machine is over provisioned. It says run this command so that you can switch to standard B2S. Then it says there is an orphan disk, delete the disk. It says there is another orphan disk, go ahead and delete it. It says there is one static public IP address that is unused, also delete the static public IP. It also provides information about over provisioned NSG and oversized OS disk. It also has the information where if I click on the history, these are the previous analysis reports. If someone wants, they can go here and look at the previous analysis. Cool. So this is our AI cloud cost detector. I hope you liked it. You can build this for AWS, Azure, GCP. Everything remains the same, architecture and request flow as well. So go through the GitHub repository, go through the prompts that I have provided. Just modify it accordingly for AWS or GCP. If you like this video, please share it. If you have any questions, do let me know in the comment section. Even if you find it good, let me know in the comment section. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, that is the third video of our AI DevOps project series, let's go ahead and build AI DevOps teammate. Trust me, you will be able to build this in 15 minutes of time. We will be using concepts like RAG, MCP, skills, but still, by the end of this video, even if you don't have mastery on these concepts, you will be able to build this. I'll show you the tools that you can use. In fact, you can use free tools, open source tools, and even enterprise tools. I'll talk about all of them in the video. So let's start the video by understanding problem statement. Then I'll explain the different tools as I told you. And finally, I'll pick up one of these tools and perform the demonstration. It's going to be very exciting. This is something every organization should have. So without wasting any time, let's get started. First of all, what is this AI DevOps teammate and why do you need this? Today, if you look at DevOps teams, they have different people within the DevOps team. Like you have junior DevOps engineers, you have senior DevOps engineers, and sometimes architect as well in the team or the DevOps team maybe. Now, what most of the people do today, so they make use of AI. It has become a common thing. They usually go to ChatGPT, or within the organization, if ChatGPT is blocked, they go to the Copilot, whichever they have access to, and they ask questions to the Copilot. Now, this is good. Using AI should definitely be encouraged, but there are two downsides to this. Two very important downsides. One, let's say junior DevOps engineers asking AI maybe for some Kubernetes command. Problem one, it can give you obsolete information. Maybe it can give you information for Kubernetes 1.29 version. Very common with AI. If you don't specifically provide it with the version, it will give you the version that is popular on the internet. Maybe it can give you old command, old version. And if you're asking for a manifest, there is a problem. The manifest is deprecated, or the API version used in the manifest is deprecated. Second problem, and the most important, security issues. Right? This is the reason a lot of companies are running into AI security attacks these days. People make use of AI, but because of the prompt that they provide, or because of the instructions that they provide to AI assistant, it can leave you with commands, or it can leave you with code. When it comes to DevOps, it can also leave you with manifests which have security issues. So how do you overcome this? So that is where you need an AI DevOps teammate. So instead of everyone using different things, one engineer in the team using ChatGPT, other one using GitHub Copilot, other one using something else, what you have to suggest, or what we are going to learn in the video, we will build an AI DevOps teammate that will be internal to your organization and internal to your DevOps team. What advantage would we get, Abhishek? It would solve these two problems, right? The first problem, again, it would solve the obsolete information problem. Because we are building it, we will make sure it returns the latest information and updated information. Second, we will ensure it does not leave any security issues within the organization, and it has the context of the organization. Context is the main thing. So within your organization, let's say you ask a question related to Kubernetes deployment. In the organization, you're using Argo CD, but it gives you the information of Flux CD. What's the point of it? Or to be even precise, okay, Argo CD is Flux CD. Argo CD and Flux CD is still something you can say, Abhishek, I can explicitly mention Argo CD. Okay, that's fine. Let's say within your organization, within the Kubernetes cluster, you have developed a proprietary kubectl plugin. Now, this is not available on the internet. This is not public. You ask AI about this. It does not have the information. So what is the point, right? It should be with the security. It should give you the secure output. Along with that, it should also have the context, right? So our AI DevOps teammate that we are going to build, it will come with three things. It will always give you the latest information. It will give you the information that is secure, and it will give you the information that is in accordance with the context of your organization, the compliance context, security context, or any internal proprietary tools context. Cool. Now the big question is, okay, Abhishek, I got the problem statement. It is clear because every one of us are running into it. But how are we going to do it? Before tools, before I explain the tools, let me first explain you the concept. How can you do it? So you need three important concepts here. One, you need agent skills. Second, MCP. Third, RAG. So when you build an AI using these three concepts today in 2026, then your AI is going to be very robust. And even the AI DevOps tool that we are going to build, the AI DevOps teammate, we will add skills to it. We will add required MCP servers to it. And we will add the RAG to it. Abhishek, what are these things? Now, I'm very new to AI. I don't understand. I'll explain this in simple words to you. You don't have to master this in today's video. In fact, even the output that we are going to build, you don't have to master this. You don't need to know the in details of it. Only the things that I'm going to explain. If you understand, it's good enough. What are skills? So, agent skills is a concept, or agent skill is a concept where you make AI, right? Or you help AI understand what kind of output are you looking for. For example, the same thing. Within your organization, you might be using Kubernetes 1.33. So within the skills, which is an MD file, which is a markdown file, you will tell agent, we are using 1.33 version. We are using Argo CD, right? We are using Istio, right? This type of information you can give to AI so that whenever it is ready to respond, before it performs the analysis, it goes to the skills.md, it sees what instructions have you provided, and according to your instructions, it will give you the output. It will not give you the output for Kubernetes 1.29, but instead, because you're using 1.33, it will modify its search and it will give you the result for 1.33. So whatever you require, you define that in the skills.md. Then MCP. What is MCP? Basically, you can provide list of tools or you can use MCP servers that are available on the internet. For example, Kubernetes MCP server. What it does, instead of your agent going to different sources on the internet, it will not search for answers on Reddit. It will not search for answers that it already has. Instead, it will go to the Kubernetes official documentation and give you the output. So this way you can eliminate security issues, right? For example, you ask your agent a question, it goes to Reddit, maybe it does not have the information of it. It goes to Reddit, it finds some information and it gives you the information back. The problem in this case is that what if the Reddit answer has some security issue? The Reddit code has some security issue. If you use MCP server, you can eliminate that because the MCP servers tell agent, if you are using Kubernetes MCP server, go to the Kubernetes official documentation and read the information from Kubernetes official documentation and give the output to the user. So your output will be secure. Okay. Then finally, what is this RAG? Retrieval augmented generation. In simple words, understand it this way. Within your organization, you have some internal documentation. Okay. Maybe you have some internal tool, or in this case, you have a internal Kubernetes plugin. Just for example, AI will not be aware of it because AI is aware of public information. It is trained on the public information. Using the concept of RAG, you can provide these documents. So you can take the documents, you can store them in vector database, right? And what AI does, if it does not have the information, it will go to your vector database. It will look for the document. If the information is available in the document, it will give you the information back. Perfect. So what RAG does, anything related to your internal organizational context, like internal documentation, internal tools, it will help AI understand that concept and give you the output. So that's why we will be building our AI DevOps teammate with skills, MCP, and RAG. In fact, any agent that you're going to build, not only this thing, but if you're building something within your organization, make sure you use these concepts. So these are AI concepts, 3 AI concepts that are very useful in 2026. Maybe down the line, we might have a new concept that can integrate all of this. But right now, this is how you build AI agents in a robust way. Now let's come to the actual thing. Abhishek, should I learn all of these concepts now? Like I have to learn how to implement RAG, I have to learn how to implement skills, MCP server. Not needed. Today, things have become very easy. All that you need is a workflow automation tool. Workflow automation tools are very, very useful for DevOps instance. For example, you have workflow automation tools like N10, Sim.ai, Retool. Of course, there are many new in the market at this point, but these are very reliable and trusted. Abhishek, which ones to go with? And what is a workflow automation tool? In simple words, of course, I'll show you in the demo, but in simple words, a workflow automation tool, you don't have to write code, you don't have to give it a lot of steps. You just have to tell it the flow chart. We call it DAG, but in simple words, layman terminology, understand? You just have to provide it with the flow chart, which tools that you want to use, what is the input, what is the output, and that's it. It will build the entire workflow for you. In this case, it can build the complete AI DevOps teammate for you. But Abhishek, which ones to use? Okay, you suggested three options here. Which one should I go with? Okay, I'll give you the options when to go with WinTool. First thing, if you want something robust, if you want something that is there in the market for a while, that has revolutionized this space, go with an I10. Or let's say you want to go with open source solution. Abhishek, I want to go with something open source, something free for my organization. Then you can go with sim.ai. Basically, it also comes with Olama integration. So you can run sim.ai using Docker Compose, integrate it with Olama, and integrate it with your local models. If your organization has something like a DGX Spark box, or if you have local compute within your organization, maybe on-premises servers, this is the best option to go with. Finally, if you're looking for enterprise solution, Abhishek, we are not bothered about money, but we are bothered about enterprise level features, enterprise level security, then go with Retool. So these are the options. N10, if you want to go with something robust, open source and free, go with sim.ai. Retool, if you're looking for enterprise option. Of course, with N10 as well, you can integrate Olama, but it's not that stable when compared to sim.ai. I know majority of you would be interested with open source solution because you want to implement the same thing. You want to show this within your organization. We will go with sim.ai for today's demonstration. But saying that, it doesn't matter. You can follow the same steps in any of these things. In fact, I made video on N10, I made video on Retool, I made video on sim.ai as well. So if you want, you can watch those videos for reference also. Cool. Now let's get to the point. How do we install download sim.ai and how do we build this tool in next 10 minutes of time? Just head to the sim.ai documentation. Just search for documentation sim.ai or link in the description, whatever you feel comfortable. Go to the Docker section. You will find the Docker Compose command. Take this Docker Compose command and you will have sim.ai running. If you scroll down, you will also find Olama integration here. So you can directly run this command to set up sim.ai with Olama directly. But make sure you have the local compute. You have the GPUs running on your machine. Otherwise, don't use this option. Because if you don't have GPUs, this will not be much use. There is option for CPU only, but trust me, it will be very, very slow. In such cases, Abhishek, what can I do in such case? Then you have the hosted solution for sim.ai as well. See if you can get some free credits. I think if you uh, install for the first time, you might get free credits. Try it. With free credits, you can build 1 to 2 workflows. That's good enough. Same with N8N as well. Same with Retool as well. Right now, I'm out of India. I don't have my uh, personal machine where I have a lot of GPUs. I'm on a different machine. So even I will go with hosted solution only. Cool. How do we do this? Just head to the hosted solution, www.sim.ai or N8N Retool. It looks almost the same. The process is also almost the same. Click on workflow section. Okay. Let's name this workflow. Let's say instead of building an AI DevOps teammate, we are just building a Kubernetes teammate. Just to make things simple. Kubernetes AI teammate. Perfect. Now what you have to do, click on this Kubernetes AI teammate. You have an option here, start the workflow. So you can use different triggers. I'll use just the simple start trigger. Then I'll go to the toolbar section, and here in the toolbars, I will just search for an agent. Okay. So I'll look for the agent option because we are building an agent. Then here you can attach this trigger in the block section to the agent. That's it. So you can see now this will start the workflow. This is connected to the agent. The agent already has the model. If you're fine with Sonnet 4.6, use it. Otherwise, you can pick up the model of your choice. If you're using Olama integration, here in the model section, you will find Olama and your local models. I'm fine with Sonnet 4.6. I'll keep it as is. But Abhishek, where is the RAG integration? Where is skills integration? Where is MCP integration? This is just an agent. This is just like ChatGPT. I can use the same thing. No. What you can do, so if you look at the options carefully, there is options for skill and skills option. So click on add skill and you can add a skill of your choice. I have Kubernetes skill. I mean, I just created it. Basically, I've added 4 to 5 points in it. Like the Kubernetes version is 1.3334. If I ask you something related to cluster administration, always return the information about these versions only. Then I provided, I'm using Helm V3. There is Helm V4 now. So I'm just saying my organization is in V3. Always return information about V3. Then I'm saying we are using Argo CD. We are using Nginx Ingress Controller, not Gateway API. And we are using Prometheus and Grafana. So this kind of information you can put in the skills and you can provide that here. Okay. So skills.md is done. We have granted it access to skills. What's next? MCP. How do you integrate MCP? Again, it's super simple. Just go to the tools section, add MCP server, and add MCP server of your choice. There are thousands of MCP servers. Literally for every DevOps tool, an MCP server is available open source. You can search for awesome MCP servers and find the best one that works for you. I'll not complicate the concept. Okay, we will skip the MCP for now, but this is how you add it. Finally, your internal knowledge base. Go to the knowledge base section. To the left side, I added a knowledge base called Kubernetes Pod Investigator plugin. So basically, I'm saying in my organization, I have Kubernetes Pod Investigator plugin. This is the documentation. In your organization, definitely you will have 50 pages, 100 pages documentation. Just go here, add that in the knowledge base. Abhishek, is it safe? See, as I told you, sim.ai can be self-hosted as well. This is a hosted solution. My bad, I told it wrong. This is hosted solution. You can self-host as well. So using Olama, you can run it locally. In such cases, there is absolutely no problem. Now, if you ask me about this particular hosted solution and is it safe or not, I mean, I'll tell you have to ask your security team because I'm not the right one to say. If you want that, then you can go for Retool, which is an enterprise tool, definitely secure. They come with SOC 2 compliance and everything your organization needs. So basically ask this to your security team. But local integration, it's absolutely safe. Go to the knowledge base and upload the knowledge base. Go back to the workflow. You will find the file section. Provide the file. The same thing. Kubernetes pod investigator. Perfect. So we added RAG implementation. We added MCP implementation. And we also added the skills implementation. Our agent is perfectly ready. It's that simple. Now, all that you have to do is click on the deploy button. This will be deployed. Just give it like 2 to 3 seconds of time. Now this is live. Oh, my bad. I forgot to provide the input here. So you just have to provide input. For example, you can provide your name, string, description. You can just say hi or something and any default value that you want to leave. You can update this. It will create another version like V2. And even here within the agents, we have to provide a message. For example, I'll just ask AI to generate the message. I'll say Kubernetes. This is a Kubernetes teammate that we're building. It will generate complete system prompt for us. I mean, if you want, you can write it, but I have provided the system prompt. Cool. Now, again, let's click on update. This will create V3 version for us. And let's ask it to run it. Cool. So now this is in the running state. But Abhishek, how do I interact with this agent? Okay, we created a Kubernetes AI teammate. How do I talk to it? Click on this agent, okay, or click on the start section. You see that live option, go to the live option. Then you have different points to communicate to the agent. For example, you can use the curl command and talk to the agent using curl, or you can use it as an MCP server. You can use it for agent to agent. No, Abhishek, I'm interested in regular chat GPT style. Click on the chat section. Just provide name to your chat URL. For example, I'll call this Kubernetes Veeramalla agent. And I will say it as Kubernetes agent. Okay. Output, I want to see the content. I want to make it public within your organization. You can control the access using password. You can control access using email and even SSO. So again, there are a lot of security options. This is the entry message, the first message. Click on the launch chat. Perfect. In 10 minutes, you have your AI DevOps teammate ready. Now just ask it a question. For example, what can you do for me? Okay. It will respond with the instructions that you have provided. It will say, I'm a Kubernetes expert. I can do these things for you. I can help you with your internal pod plugin. Let's see. There you go. Welcome. I'm your Kubernetes expert. I can help you with the Kubernetes 1.33 Argo CD Nginx Ingress controller. I can help you with the architectural design, deployment strategies, and it also says like I can do all of these things for you. If you want, ask me. My pod is stuck in crash loop back off. I can help you with diagnosis. I can help you with any issues with Argo CD. What would you like to explore? So just like your ChatGPT experience, but with MCP, RAG, and most importantly, skills. So your AI DevOps assistant or your AI DevOps teammate is ready. Isn't this cool? Now go back, build something by yourself. You can use sim.ai, you can use N10, or you can use Retool. Wherever you get some free credits, or if you can host it on your local machine, go ahead, host it and try it. I hope you found today's video insightful. Let me know in the comment section if you have any question about it. And even if you like it, leave the feedback. See you all in the next video. Take care. Hello everyone. My name is Abhishek and welcome back to my channel. In today's video, let's take a look at a very interesting and very useful AI DevOps project, AI Kubernetes Upgrader. Now, by looking at the name, I'm sure you must have guessed it. We will use AI. So basically, we will create an AI tool in this project, which will help DevOps engineers with Kubernetes upgrades. Now, why is this a useful project? Let me ask you a simple question. Why do you want to use AI? Or why your organization is pushing you towards using AI? The simple answer is to automate the manual activities or automate an activity that you do time and over again. Now, Kubernetes upgrades are one such activity. Every 3 months, Kubernetes comes up with a new minor version. Let's say the current version is 1.34. Kubernetes comes up with 1.35 in the next quarter. On top of that, there are sub minor releases, which is also called Z stream releases. Like, let's say if the current version of Kubernetes is 1.35.6, just as an example. If there is a issue with Kubernetes, or if the Kubernetes maintainers have fixed the bugs, or let's say there is a vulnerability with Kubernetes, instantly you see 1.35.7. And this keeps happening. So every 3 months, it's a regular activity for DevOps engineers to upgrade the minor version of Kubernetes. That is, let's say from 1.34 to 1.35. And in between, again, it's a regular activity to upgrade the sub-minor versions, which can be 10, 12, or you never know. It depends on the bugs. It depends on the critical vulnerabilities. So this is a super tedious activity for DevOps engineers, especially the ones who are managing their Kubernetes clusters. A lot of companies still do this. They manage their own Kubernetes clusters. They don't go for EKS, AKS, or other things. And even on EKS, some companies they take care of their upgrades themselves. So now the question is, because this is a super tedious activity, why can't you use this AI Kubernetes upgrader within your organization? Or why can't you build something like this of your own? Exactly this is what you need at the moment, especially if you're taking care of your Kubernetes cluster upgrades. And if you're planning to get into DevOps, like maybe a fresher or from a different stream, you can use this project. You can show this in your resume, on your GitHub, on your LinkedIn, and you can showcase this as your AI DevOps skill. Perfect. Now I hope the problem statement is clear. Why are we doing this AI Kubernetes upgrader? Now let's deep dive little more and first try to understand, like before we build this AI Kubernetes upgrader, what level of manual activity is involved? Okay, Abhishek, like we upgrade from minor versions, we upgrade the sub-minor versions, but what is the role of DevOps engineer while upgrading these things? So you can understand the scope of this project better. So basically, every time, let's say there is a minor version upgrade, 1.34 to 1.35, DevOps engineers perform the following things. First, they look at the release notes. So release notes are important because they give you a clear picture. Kubernetes release team writes this. They provide the information what changed within the release, how many features are added, how many bugs are fixed, and what is the scope of those features or bugs. And then DevOps engineers also make sure they have backup because let's say something goes wrong, they need to fall back. So they have the backup of the existing cluster or cluster resources, any fallback mechanism or the failover mechanism. Then they verify the cluster health before upgrading. Especially in lower environments, this is important, like the dev environment, staging environment, because these clusters are always messed up. When you give your dev environment to your developers, they might deploy different resources on it. They might uh, install different CRDs on it. So there is a huge possibility that the cluster health is messed up. So DevOps engineers also look at the cluster health, different APIs, and only if the cluster health is right, they proceed with the upgrades. And then they start with the control plane upgrade. So these becomes the prerequisites. And then the actual work starts with the control plane upgrade, which is kind of simple when compared to the data plane upgrade. So in the control plane upgrade, basically they look at different control plane components and see how to upgrade them. Like what are the different components that are involved in this. Then they upgrade the worker node once at a time. Right? There can be 6 node cluster or 3 node cluster. So what DevOps engineers usually do, they pick up one worker node, complete the upgrade, and then move to the other worker node. Just if you want to understand this in detail, basically they start with cordoning a node, right? Basically they make a particular node unschedulable. Let's say they want to upgrade the first node out of 6. They first cordon this, they make it unschedulable, so no new pods get into this. And then they drain the node. So the existing pods, they move to the other 5 nodes. And once they ensure these steps are done, then they start with upgrading the Kubernetes components on the data plane, like kubelet or kubeproxy. Then they reboot and finally uncordon and verify if the new version is added. Of course, then they attach the worker node to the control plane. So many steps are involved, and these are very sensitive steps. And finally, verify the cluster once the control plane is upgraded, data plane is upgraded, sometimes the cluster add-ons like core DNS and all. Finally, they validate the upgrade, and in some cases, let's say there are some sensitive environments, DevOps engineers also monitor the cluster upgrade. Maybe for 1 week or maybe for 2 weeks. They see if the new cluster upgrade is not creating any issues for the organization. Now imagine how much time this would take. Let me tell you, this can take 2 to 3 days as well. At times, when the worker nodes are more, when the environment is sensitive, this can go up to 2 to 3 days as well. Now, after 2 to 3 days of effort, if any of these checks are not verified well, right? Maybe when they are looking at the cluster health, they did not look at the cluster health well. The 2 to 3 days of effort is wasted. Instead, we can get this done by AI. Now, there is a fine line here. What you need to understand, I'm not building a project and I'm also not recommending you to build a project that would use AI to upgrade the Kubernetes cluster. No, I'm not saying to build this. I'm saying use AI to see the feasibility, or AI that can assist you and tell you, yes, this upgrade is possible. I'm 80% confident that it would not mess up your cluster after the upgrade. This is important, right? Once you have the feasibility, yeah, you can go ahead and upgrade the cluster even if it takes 2 days of time. After 2 days, you have a new version and your effort is not wasted. Now you might say, but Abhishek, then the valid name for the project is AI Kubernetes Upgrade Validator. Yeah, it's fine. If you want to call it, you can call that as well. Or if you want to combine both of these capabilities in the future, once you use this feasibility or validator for, let's say, 6 months, you're confident about it, then you want to also add the upgrade capability, you can also add that. But initially, just start with this, because trusting AI for upgrades at this moment is not a good idea. Nice. So how are you going to build this project? I'll first start with the toolset. We'll keep it very simple, especially for this project. I'll use Python for building the required CLI. We don't need user interface for this project. CLI is good enough. And then coming to the models, I'll go with OpenAI API. But if your organization is very strict about the data, you can also use Olama with local model integration. But for this, you need GPU compute. Maybe you can spin up a machine on AWS, Azure, or you need something like a DJX Spark. That's it. We will only use these two things in the project and we will be able to achieve this. Coming to the Kubernetes cluster, I'll use a local Kubernetes cluster, the kind cluster, because to spin up an EKS cluster and verify the project on the EKS cluster, it takes a lot of money. Instead, we'll go with kind setup. Let me also talk about the architecture so that you can understand better. Now, what happens once we build this project? User gets to access the Python CLI, the tool that we build. What this tool does, it takes input from the user. What version are they planning to upgrade? Let's say they provide the version as 1.35. Now CLI makes use of kubeconfig. Abhishek, how to make this more sensitive? Within your organization, let's say if you're using SSO, you can make use of tools like Auth0. So you don't have to use kubeconfig. But this is a good first start. CLI makes use of kubeconfig. It gets the current state of the cluster, like what is the version of the cluster, what are the APIs in the cluster, and all that information. Now, in the meanwhile, CLI makes use of OpenAI to fetch release notes of the Kubernetes cluster. I mean, the release notes of the new Kubernetes version. And then this state information, whatever CLI gathers, let's say the different CRDs on the cluster or the different APIs on the cluster, how many nodes on the cluster, all that information, this will pass the information to the OpenAI. Now, using the release notes and the current state of the cluster, OpenAI performs the validation. And once the validation is complete, it will give a detailed summary back to the user. This is the architecture that we are going to follow. I'll repeat this one more time because architecture is the critical piece. And then we will head to the implementation. So user interacts with the CLI component that we are going to build. We will make use of Python to create this CLI utility. CLI takes input, the version, the target Kubernetes version. Let's say if it is 1.35, CLI makes use of kubeconfig. It gets the current state of the cluster, everything that it needs using kubeconfig, like the kubectl commands. In the meanwhile, CLI makes use of OpenAI. It gets the release notes of the new Kubernetes version. Then using this release notes and the current state of cluster, OpenAI. So basically in the CLI, we will make an API call to the OpenAI API. We will go with a particular model version. It performs the validation, and post validation, it will share the steps like the detailed summary. If the validation will be, if the upgrade can be feasible, not feasible, what is the level of confidence, a detailed summary to the user. Perfect. So now you understood the tools, you understood the architecture. Let's head to the implementation part. Now for the implementation, we will use GitHub Copilot with Visual Studio Code. But the big question is, what prompt are you going to provide? It has to create the Python backend or the CLI for you. It has to set up OpenAI integration. You are not going to write all of this. The prompt is going to be huge because this is a very, very critical activity. There are so many things the CLI application has to take care of. So what I've done, I've created this prompt for you, and I've also put this prompt in the GitHub repository. So now I'll take time to go through the prompt. This is a very, very important thing. See very carefully how I created this prompt and how many sections are included in the prompt so that in almost one go, the GitHub Copilot can build that CLI application for us. First, I started with the objective saying, you are acting as a senior Kubernetes platform engineer, or you can say senior Kubernetes DevOps engineer, performing a comprehensive upgrade readiness review. Not the upgrade, but the readiness review of the upgrade. Your task is to determine whether Kubernetes cluster can be safely upgraded or not. Source version and the target version. Then I'm saying the analysis must be exhaustive, evidence-based, and conservative. So that basically I'm saying AI agent, don't overthink. Your primary goal, anything that can break during the or after the cluster upgrade, unsupported APIs, controller incompatibilities. Basically, let's say you're using Istio. Maybe post upgrade, the version of the Istio that you're using is not compatible because of anything, or it might break. CRD incompatibilities, admission, webhook risks, operator risks, runtime risks, networking risks, storage, security, workload, node upgrade risks, and control plane risks. If you feel you take care of anything else within your organization, just add that point to it. The prompt is already curated. You just have to modify something in the prompt. Do not assume. This is something that you have to tell AI every time so that it does not hallucinate and overthink beyond your requirement. Now the assessment requirements. Okay, I've provided what assessment requirements it has to take care of. Then I have provided the step-by-step integration. For example, gather cluster information. But Abhishek, why do I have to give this kubectl commands? AI knows what kubectl commands it has to take care of, right? AI knows what information that it has to fetch from the cluster. The problem is that if you don't give this information, it will go crazy. It will perform n number of kubectl commands, and it might charge tokens for you, your compute power, which you definitely don't want to happen. So that's why keep the kubectl commands. If you're already performing Kubernetes cluster upgrades, you would have that document somewhere in the Confluence. What steps do you usually take care of? Put those kubectl commands here. That's it. So that AI does not overthink. In the step two, I'm saying inventory resources, what it has to collect. Then the install CRDs, what CRDs it has to collect. Controllers, what controllers it has to collect. Now this differs from organization to organization. I put the popular controllers here. If you want, you can also list the controller within your organization. Or you can tell AI, use the kubectl get CRD and get all the CRDs so that it knows the controllers. Analyze Kubernetes release notes. As I told, this is something that the OpenAI integration is going to take care of within the Python CLI. API removal analysis. Then I provided the steps, take care of deprecated AI analysis, CRD compatibility analysis. What I actually did, I have a notes of Kubernetes upgrades. Like when I am performing a Kubernetes upgrade, I have detailed notes what I usually take care of. That's in the GitHub MD file. I provided that MD file. I, kind of modified it and I put them in the organized format in the prompt. So that's why the prompt is very, very detailed. On top of that, if you go to the, towards the end of the prompt, I'm also saying how the output should look like. So I'm saying this is what I have to say. Control plane, pass, good, warning, nodes, APIs, CRDs, controllers, networking, storage, security, and finally the failure analysis. So I don't have to, you know, worry about is networking good, is controller good. For each and every component, it is going to provide me with pass or fail. Perfect. So take some time, go through the prompt. It is a very, very huge prompt. I kind of intentionally made it very huge so that the application is built in one single go. Now we will take the raw format, right? Copy this entire thing, put this in GitHub Copilot. If you want, you can go with the auto mode or you can select a specific one. Claude Sonnet 4.6 is good enough for this. Okay. So all the prompt is here and I'll go ahead, click on the start. Now this would probably take 10 minutes or 15 minutes for the entire CLI to be built. Once we have the CLI, we will take a look at the next step. Nice. So we have the output ready. So I just created main.py file. I was going through it. So Python main.py, you just have to provide the source version, target version. And if you want to see the output in a report, you can also provide -o report.md. And before that, you have to execute the dependencies. Let's see what all did it do. On top of that, yeah, it created a .env file where you can store your OpenAI secret or your Olama integration related things. In the main.py file, again, I was going through it. It was fairly simple. So list of dependencies, then list of kubectl commands that it is going to execute, whatever we provided in the prompt. Then it is going to execute these kubectl commands, the CLI. It is going to gather the cluster data using the CLI commands. Then it is going to use OpenAI. So this is the prompt that it built. It shares the cluster state. It also gets the release nodes information. And here it is performing the analysis. And finally, it is sharing the output with us. So all as expected, at least looking at the source code, looking at the instructions, I feel this should work. But you never know. So we'll go back to the terminal. First thing that we'll do, create a Kubernetes cluster and test this out. So using kind, let's create a little old Kubernetes version, right? So that we can upgrade it. Kind, create cluster, hyphen name. Let me call this as K8's 1.34. Okay, I'll spin up 1.34 version. How do I do that? I can just say hyphen image kind set slash node colon 1.34.0. I hope the command is right. Okay, so it is spinning up 1.34 Kubernetes version for us. All good. It should spin up the cluster in less than 1 to 2 minutes for us. Because it does not have the node image, probably it would pull the image. Error response from daemon, pull access denied for kind node set. Let's see. Yeah, there you go. So we have the cluster ready. So basically there was a typo. I just changed it to kindest and also changed the version from 1.340 to 1.343. Looks like this image does not exist. Cool. So we have the kind cluster ready now. Let's clear the screen now. I'll switch to the folder. So this is in the downloads folder. The project is AI
Kubernetes upgrader. Perfect. We will start with creating a virtual environment because whenever you work with Python, it is recommended to create virtual environment so that dependencies does not mess your system. So Python 3 hyphen m venv. Let me call this as .venv. And let's source the virtual environment. Source.venv slash bin activate. Let's first install the dependencies. Pip install hyphen r requirements.txt. Okay. So this is pulling all the dependencies that we need to run the main.py. This will also have the OpenAI dependency. And just to tell you, I've already updated OpenAI.env. The .env file with OpenAI API key. And this is the model that we are going to use, GPT-4o, because this consumes less number of tokens. Okay. So now let's try Python 3 hyphen m, my bad, Python 3 main.py. Source version, I'll call the source version as 1.34, target version 1.35, and hyphen o report.md. Now it knows which Kubernetes cluster it has to upgrade because it is using kubeconfig and kubectl. So it is connected to the Kubernetes cluster that we just created. And there is nothing in the cluster. So let's see what does it say, if the upgrade is feasible or not. And also let's see how confident it would be about the upgrade. Okay, so it is collecting all the information very fast. It connected and collected the cluster data. Kubernetes upgrade feasibility, streaming assessment from GPT-4o. Okay, it is performing all the assessment you can see here. Step 1, step 2, step 3. This is what you would have done manually. Now AI is doing it for you. Okay, it performed all the assessment. Looks like we are almost ready. Yeah, and it stored the assessment here. Let's copy this file and read it. I'll open the file. What does it say? Or let's open this in the MD file, Vim file format. Vim report.md. Okay, generated Kubernetes upgrade AI. This is a model that it used. Assessment for 1.34 to 35. Step 1, gathered the cluster information. Let's go to the bottom. Cool, you can see here, source version, target version, readiness score is 85 by 100. That means, AI cannot give you 100% readiness. When you see 85, that means your cluster is ready to upgrade. Confidence is 70%. So that itself says it is 70% confident. If you want to go high, use higher reasoning or higher thinking model, maybe like Claude Opus 4.8, or if you're using OpenAI, maybe you can go with GPT 5.5 or above model. But yeah, readiness score is 85 and confidence is 70. It says high risk. None of the high risks are detected. So you are perfectly good with the cluster upgrade. Now you can go and manually perform the cluster upgrade. Or if you want, you can share this report with your management saying that this is the analysis we have performed. Now everything looks good. Control plane status looks good. Node status looks good. CRD status is passed. So we are proceeding with the upgrade. I shared the prompt in the GitHub repository. You will find the link in the description. Go ahead, try this cool project at your end. It would hardly charge you less than $1. If you have access to GitHub Copilot, that is more than enough. Or any agent. It can be Cursor, Claude. You just need access to it and less than $1 for your OpenAI integration. Or if you have Olama, you can do it locally as well. I hope you found this project useful. This way we are creating a lot of AI DevOps projects on the channel for absolutely free of the cost. You can find AI DevOps project playlist on the channel. See you all in the next video. Take care.
Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's build a very interesting DevOps tool using AI. So basically, one of the very common challenges for DevOps engineers is identifying the infrastructure drift. Creating infrastructure is easy. Today, tools like Terraform can create the infrastructure for you. But the manual changes by developers to the infrastructure creates a drift. And this drift is literally a nightmare for DevOps engineers. In today's video, let's build a tool that can identify this drift. So basically what we are going to build is a Terraform drift detector. Now this is going to be very interesting and I want every one of you to build this. So I'll break this down in 4 simple steps. Step 1, I'll explain you the problem statement. If any one of you is not clear about infrastructure drift, I'll explain this in the step 1. Then in the second step, I'll talk about the tools that we are going to use. We will use the most powerful tools to implement this project. Then in step 3, I'll explain you the complete architecture, end-to-end architecture, and how the components are going to interact. And finally, step 4, we will head towards the implementation. Once again, this is going to be very interesting. So make sure you watch it till the end. And all the useful links for this video are in the description. So make sure you check out the description as well as the pin comment. Perfect. Without any further delay, let's get started. Let's start with the problem statement. What exactly is this infrastructure drift? Let me explain. One of the common DevOps activities today is to create infrastructure. DevOps engineers don't create the infrastructure manually. They use infrastructure as code tools like Terraform. What Terraform does? It takes input from DevOps engineers in HCL file format, HashiCorp language. It converts this HCL file into bunch of API calls. API calls to cloud providers like AWS, Azure, GCP, and multiple other providers that Terraform supports. Now these API calls create the infrastructure on the cloud platforms. This is the process. Terraform is super cool because now DevOps engineers don't have to learn bunch of API calls. They just have to learn HCL file format. But there is a problem here. Terraform remembers the infrastructure that it created using a file called statefile. And this statefile updation is unidirectional in nature. When Terraform creates the infrastructure, it updates the statefile. But what if some developer or some DevOps engineer manually updates the infrastructure, maybe during an incident, which is very common in the organizations. Now, this infrastructure updation that is done manually is not notified back to Terraform. Terraform does not have a mechanism at the moment, and Terraform does not update the state file. This is called as infrastructure drift. Terraform does not have the latest information of the infrastructure on the cloud platform. And as I told you, this is a nightmare for DevOps engineers. Sometimes they take days of time to fix this. Because there is no official mechanism in Terraform at the moment, we are going to build this Terraform drift detector in today's video. This drift detector can be run as a cron job, maybe once in 60 minutes, once in a day, whatever is the organizational requirement. This identifies the drift and this sends an email notification or shows the drift on the terminal so that DevOps engineers can immediately fix the drift, either by updating the state file manually or by revoking the infrastructure changes that are done manually. So this is the problem statement, and this is exactly what we are going to build, Terraform drift detector. Now let's talk about the tools that we are going to use to build this project. First and the most important one, the AI coding agent. We will go with Cursor 3. So Cursor 3 is the latest version of Cursor. If you haven't used it till now, the user experience is super cool and it comes with very interesting features. For example, with Cursor 3, it is very easy to run multiple agents in parallel. Like you're working on a task, maybe using an agent, you can kick off another to keep moving in parallel. On top of that, with Cursor 3, you can literally build and ship from anywhere. You can use your mobile phone and you can use one of their agents and ship the application. On top of that, switching between local and cloud is also very seamless. Let's say you kick off a long task in cloud. Then once you're good, you can pull it to local, probably add some tests, or polish the details. I'll show all of this using the user interface. Then what about the model, the large language model? We will go with Composer. To be specific, we will go with Composer 2.5, which is the most intelligent coding model developed by Cursor. Composer is also very cost effective, and when you are dealing with sustained work, or let's say you are dealing with long running tasks, Composer is very reliable. Now I know what you're thinking, but Abhishek, what about comparison with frontier models? Don't worry, Composer is on par with the leading models on the Sway Bench Pro. Cool. Then what about the cloud platform? Where are we going to create the infrastructure? We will use AWS. And for infrastructure as code platform, we will go with Terraform. Obviously, we are building Terraform Drift Detector. And finally, the coding language, we will go with Golang. Of course, we are not going to write the code, but still it matters because you are building an application. This is a very simple and efficient tech stack for our project. Now let's take a look at the architecture. At the core of the architecture, we have the drift engine. What is the responsibility of the drift engine? It compares the resource information in the Terraform state file against the actual information on the cloud platform. I mean the actual resource information. Now this is tricky because Terraform state file stores the information in the TF state file format, and AWS has this information in the JSON or YAML format. So what we have to do for Drift Engine to compare these things, we have to bring both of them into a common format. Of course, first we have to extract the information and then we have to get them in a common format so that Drift Engine can compare it. So what we will do, we will get both of them into the Ghost structs, right? Because in Ghost structs, we can put this information in a very flexible format rather than bringing both of them into JSON or bringing both of them into YAML format. We will put them in a Ghost struct format, and Drift Detector will compare both the structs and tell us by either providing a JSON report what is the difference, or maybe it prints on the console output, whatever is feasible, or we can do both of them as well. Now for this to happen, there are different components here. Let me walk you through it. First, there is a state reader. What state reader does? State reader extracts the information from the TF state file. Initially, it gets this information in the JSON format, and then from the JSON format, it puts this information in a Ghost struct. Similarly, there is a cloud fetcher. Cloud fetcher makes use of the cloud APIs, in this case, AWS APIs, gets the information in the JSON format, and then the JSON format information is put in the Ghost struct format, right? Now, on both the sides, we have information in a structure. So Drift Engine compares it, generates a report, or prints the output to the terminal. Now, the biggest challenge here, as I told you, is getting both of them in the common format. And this would take a lot of time in general, because first you have to understand all the types of resources. Then you have to prepare a structure. You will have to go through multiple iterations. This would easily take 2 to 3 months of your time. Let's say you are an expert, or if you have worked on a similar solution in the past, this might take 1 month to 45 days for you. Now we will use in the implementation part, now that we understood the architecture, we understood the problem statement and the tools that we're going to use. Now let's head to the implementation part and let's ask Cursor agents to build this entire solution for us. Okay, now for the implementation, we will start with Cursor 3. It's very easy. Just head to cursor.com/agents or use the link in the description. That will get you to this page. Once you're here, create an account. And once you create an account, you can start with creating a new agent. As we learned, you can create multiple agents and you can run multiple agents in parallel as well. Okay, so we will choose the model first. So I'll go with Composer 2.5. There are different models, but as I told you, Composer 2.5 is token efficient and it is also on par with the frontier models. So I'll go with this. And then I'll select the repository. Now, why are we selecting the repository? Very simple. The cursor agents are capable to create a pull request and push the code to your GitHub repository as well. So like literally you don't have to interrupt in the middle. You can create the whole application and you can push the code to your GitHub as well or create a pull request for peer review. Okay, so I have this empty repository, Terraform drift detector. Now cursor is connected to it. Now let's provide the requirement. But what I'm going to do, because this is slightly complex, what we are going to build, first we will create a plan, right? Instead of directly generating the code, we will first create a plan. And once we have the plan, and once we are okay with the plan, only then we'll go ahead and ask the agent to implement the code base. So this is the prompt. Build a Terraform drift detector platform that continuously compares Terraform state files against actual cloud infrastructure to identify the configuration drift. The system retrieves expected resource metadata from Terraform state and actual resource metadata from cloud provider APIs. Normalizes both in the common model and highlights the differences such as deleted resources, modify attributes, and tax changes. Users can run scans on demand or schedule and view drift reports through simple dashboard CLI or JSON format. The solution should be cloud agnostic, extensible, and optimized for fast infrastructure visibility without requiring Terraform plan or apply operations. And here I have an option. Let's say for this entire thing, I can also share the architecture diagram, which is good part because we already have the architecture. Like I've explained you the architecture sometime back. I provided the same information here. Now cursor can generate the code much better, but initially I wanted to plan the entire thing before writing the code. Let's go ahead and see how this works. So it is setting up a new cloud agent for us, Composer 2.5 Terraform drift detector. On the left side, you can see this new cloud agent. The environment is getting ready, planning the next moves. Nice. You can see here it worked on the plan for 1 minute 45 seconds. It generated the goals and no goals. You can go through the goals and no goals if you're okay with it. Then it again generated a high level architecture from the high level architecture that we provided. This time it provided more detailed architecture. It also shared the core data model, what it is going to build. As I told you, this is the key part. Entire thing is in the Go struct. So it shared the Go struct that it is going to build. And it also provided the component design, like how would the state reader look like? How would the cloud extractor look like? How would the drift engine look like? A high level schema of what it is going to build. And then end of the day, this is going to be a CLI application. So it also named it as drift CTL and it shared the commands for the drift CTL as well. It is going to run these commands internally. That's fine. Or we can also run this drift CTL commands. It also provided an option for cron job. So you can see here, this is how you can run the cron job for it. Then further, it also added the complete workspace structure. So if you're okay with all of this, so this is the plan it generated. If you're okay with it, we can just say, please proceed with the implementation. Or let's say if you need some changes, you can discuss here with the agent and you can further modify it. I'm super happy with it. Please proceed with the implementation. And there are few things here which I would like to mention. MCPs. Right now, we don't need an MCP server for this project, but let's say you're dealing with some information, maybe external to the agent. You can add an MCP server so that agent connects to the external documentation and fetch the latest information. And even if you want, you can provide multiple models. Okay, we are going with Composer, but let's say you want to choose 2 to 3 models. Even Cursor supports it. Perfect. Now let's ask it to go ahead and implement it. Let's see how it implements. Okay, it is implementing the next steps. So you can see the steps it is going to implement. First, it is going to scaffold the Go Meno repo. So entire thing is going to be in a single repository. Then it is going to implement the core model. Then it is going to implement the AWS provider, implement the drift CTL, and finally it is going to add tests, config examples, README, and it is going to push this entire thing as a pull request to the Git repository. If you want, you can directly push it as well. Also, I want to mention one thing here. This is a cloud agent, so you don't have to wait for this completion. You can go ahead create a new agent. Let's say you're working on something else. You can start building another application or another project as well. In fact, they have an option for agent demos. Let's say if I enable agent demo for this cloud agent, once agent completes the entire work, it provides a video demonstration for us so that we don't have to review the code base. We can just review the demonstration that agent is created. Like just like how we create demonstrations for the project that we create and present it to our team members, agent can create a demo and share with us, right? So you can go ahead and work on something else. Meanwhile, agent creates this Terraform drift detector. Anyways, going back, I can see it started building the SQLite Go, store.go, provider.go, aws.go. Looks good. Okay, now it says the implementation is complete, at least the first part of the implementation. Let's see what did it build. So it created the state reader, state extractor, AWS provider, drift engine, scan orchestrator. Now it is saying that we just have to go ahead, run the make build. And once the make build is complete, we will have the drift CTL. So we can run this command. This is for, this is just a dry run. And then we have a live AWS scan. We just have to export the AWS region where we have the actual infrastructure. And then we have to run this command so that it provides a information of the drift. Now you might say, but Abhishek, where is the code base? Okay. Cursor agent created all the files for us, this entire structure. Where can we find the code base? You can just head to the GitHub repository. So this is my repository, Terraform Drift Detector. You can see a pull request is created. Implement Terraform Drift Detector platform using Drift CTL. And this pull request, this is a very well curated pull request. You can see the complete summary, implements Drift CTL, provides the architecture, what's included, how to use this. And if you want, you can also open in Cursor. Let's say someone's reviewing the pull request. They can also open this in Cursor. Probably they can perform the code review. And all the files are here. So this project has a 31 files. All the 31 files are created and pushed as part of the pull request. Now I'll go ahead, merge this, and then I'll download this GitHub repository and then try to execute the drift CTL. Cool. So let's see. I will add myself as a reviewer, assign to myself. Okay. I'll just scroll down. I'm fine with it. Ready for review. I'll change this and merge the pull request. Perfect. So now we have the complete code in the GitHub repository. I'll just go back, Terraform drift detector. There we go. With the README file, with the architecture, and with the code base. But before we actually download it and run drift CTL, we need some infrastructure created by Terraform. Let's do that. I have an AWS account. Let's simply create a S3 bucket using Terraform on the AWS. So Terraform creates a state file, and then we can execute the drift CTL. Let me pull my terminal for this. Okay, so I have this terminal. There is a sample Terraform project in here. You can see the main.tf file. Let me open this for you. So the main.tf file, it has the Terraform block, and then it has the provider as AWS. My AWS credentials are already configured, so we don't have to do that. And then it is going to create a bucket. Name of the bucket, my unique drift detector bucket 12345. I just given a random name to it and some simple tags on the bucket. You can see I haven't complicated the bucket creation, very basic configuration. Now let's go ahead and run Terraform. I'll just do Terraform init first. I hope I have Terraform installed and configured. Yeah, good. So now it is initializing the repository for us. There you go. It initialized the project. Now let me run Terraform plan. I can in fact run Terraform apply first, but Terraform plan. Let's see if all our Terraform main.tf file is good and it is going to create an S3 bucket for us. Okay, one resource to add, all good. So now I'll run Terraform apply. Okay, I'll say yes. There we go. It says a bucket is created. Let's verify this on my AWS account. Okay, so this is my AWS account. Let me search for S3. Perfect. So the bucket is created. And we also have the state file locally here, right? This should create a state file for us, terraform.tf state. Don't worry, you can have the Terraform state file anywhere. You don't have to have it here. The application that we created, we can provide the location of the Terraform state file. If it is local, it picks up from the local. Let's say you have it in the remote backend or you have it secured somewhere. The project is capable of reading your state file. Nice. Now let's pull our project. So the drift detector, I'll just copy this. I'll go back to my terminal. I'll switch to the downloads folder. I'll download this using git clone followed by the URL. Perfect. I'll switch to the Terraform drift detector. All good. And now I'll follow the instructions as per the README file. Or I can also look at the cursor agent, but it created the README file. It says all that I need to run is make build. Let me run the command. I'm not sure if I have make installed. Let's see. Good. So I have make installed. It is building the project. Let's wait for it to build the project and then we can verify. Good. So it created the artifact for us. Now we can verify. I'll just do /bin followed by drift. Okay, we have the drift CTL here. Now we can follow the instruction. So we want to compare the local state file against AWS. So what we can do, we will provide a scan hyphen hyphen state. So scan hyphen hyphen state followed by the state file path. In our case, state file is in downloads. Within downloads, we have sample Terraform project. So let me put that here and then the Terraform state file. Okay, then what's the next thing that we have to provide? We just have to say hyphen hyphen provider AWS. Okay, and region. In my case, the region is AP South 1. So I choose the region that's nearest to me. Let's run it and see what happens. Wow, that's super fast. You can see here, it says in the summary, total resources are 1. Absolutely. Missing in cloud is 0. Extra in cloud is 0. Attribute changes are 2, which is expected. Tag changes, total findings 2. So what does it say? There is nothing that is serious. Only thing, there is a warning because of the attribute changes. We can ignore that. What's important? These two fields, missing in cloud and extra in cloud. So it says my Terraform state file, the one that I've provided here, is exactly in sync with the resource that is created on the cloud platform. Let's see what I'm going to do now. I'm going to tweak the S3 bucket, right? We will modify the S3 bucket. We will make a minor change or major change to it and see if our drift detector can identify it. So I'll click on the bucket. I'll go to the properties. I'll try to add a new tag here. It's a trivial change, but still, I'll add a tag name Abhishek. Okay, save the changes. Successfully added one user defined tag. Now let's go here. And what I'm going to do now, I'm going to rerun this. Now you can clearly see that total findings have changed to 3. As I told you, this is a trivial change. So missing in cloud, extra in cloud, this did not affect. But apart from warnings, there is an info message that you have to act upon. So it says there is a new tag on the S3 bucket. The value of the tag is Abhishek. So our drift detector is clearly working. It can even respond to the trivial changes like tag changes. Very useful when you're working in production environment or very useful when you're working in a critical environment. Even the tag change is crucial. Now let's finally put this to an ultimate test. So what I'm going to do, I'm going to delete an S3 bucket here, right? So let's say there is a developer or there is a junior DevOps engineer accidentally deleted the bucket or maybe intentionally deleted the bucket. Now this is a major impact, especially if you're working on critical environments. If someone deletes a resource from cloud, And as a DevOps engineer, if you are not aware of it, if your Terraform is not informing you about the change, then it's a crucial issue. Now that we have developed this drift CTL, let's see if it is able to identify it. So I'll run drift CTL again. I haven't changed any parameters, the same state file, same AWS account. You can see here very fast, like I think it only took less than 2 to 3 seconds. It was able to say missing in cloud is one resource. Okay, obviously, when you have more resources, the comparison would take little more time, but Go is usually fast. So you might have this difference in 30 seconds of time. So we can see missing in cloud is one, and it is clearly saying the security risk is critical. The missing resource is my unique drift detector bucket 1, 2, 3, 4, 5. Just imagine when you have hundreds of thousands of resources on cloud and your drift ZTL is clearly able to pinpoint this is the missing resource. This is the resource someone deleted from your team. Wouldn't that be awesome? Yes. So that is our drift CTL. And can you imagine? We have built all of this using cursor agents in, I think, probably an hour of time or little less than that. And even if you look at the observability aspect of it, so if you want to see the amount of tokens that we have spent, or if you see the spending of this project, so you can go to the usage. We literally spent 0.32 US dollars on this. So that is why I've chosen Composer for this project. So Composer is token efficient, as I've already told you. You can see that on the observability aspect as well. So today I just used 0.32 US dollars. Even on the spending, you can find the similar information. Perfect. And you can see our Terraform drift detection is completely merged. And this is a working project. And I made this project open source. You can also go ahead. You can use this project. If you are interested, you can build on top of this project. I'll keep this project open source. Let's collaborate on this and let's build a Terraform drift detector for production use cases. Perfect. So isn't this a wonderful utility? Definitely yes. Personally, if you ask me, every DevOps team should build something like this because infrastructure drift is a major challenge. And if you have noticed in the video, we built this in a super efficient way because we use Cursor 3 in combination with Composer 2. And the best part here is that Composer 2 is token efficient. So you don't have to spend a lot of token in planning and building this project. Once again, all the useful links are in the description. If you want to download Cursor 3 and start using Composer 2 to build a project like this, you can check the link in the description or in the pinned comment. If you have any questions, do let me know in the comment section. I'm more than happy to respond. See you all in the next video. Take care.